What's going on, everybody? It's your bro, hope you're doing well, and in this video I'm going to explain how we can get started writing code in C. So sit back, relax, and enjoy the show. If you wouldn't mind, please like, comment, and subscribe. One like equals one prayer for the YouTube algorithm. I'm gonna tell you why you need to learn C. C is a middle-level language that originated in the 1970s, and it is one of the most widely used programming languages to date. On a spectrum of high-level languages to low-level languages, C is a middle-level language. Low-level languages are efficient, they work closely with machine architecture, they consume less memory, and they're fast as fuck. However, they're difficult to understand, and it takes more time to write code that's in a low-level format. High-level languages are easier to work with, easier to understand, they allow for more abstraction, but they're slower, they use more memory, and they're abstract, so it's difficult to work with low-level hardware and systems. A major advantage of middle-level languages is that they can act as a bridge between high-level software and applications, as well as low-level hardware and embedded systems. Most compilers, kernels, and operating systems are written in C. Nearly all programming languages are influenced by C in some way. C is what provided many of the original programming concepts such as variables, data types, loops, arrays, functions, etc. In fact, the Python language is written with C. The default implementation is known as CPython. If you're already familiar with the programming language, learning C will give you an even deeper understanding of how those operate. C is literally everywhere, from databases to self-driving cars, operating systems to embedded systems. It's been around for so long and used for so many purposes. Here are some important notes before we get started. C is not an object-oriented language. It's procedural, not abstract. C++ is an object-oriented extension of C. If you know C, you already know some C++. However, C is a difficult language for beginners. Don't get discouraged, you can do it. So what you'll need an IDE, an integrated development environment, which is basically a fancy text editor to help us write C code, as well as a GNU compiler collection, which we abbreviate to simply GCC. This compiles or otherwise converts C code to machine code. You know, all those ones and zeros that a machine can read. Let's begin by downloading an IDE. I recommend VS Code. It's flexible and you can use VS Code for more than just C. Alright, what you're going to do is head to code.visualstudio.com and then look for this drop-down menu to install for your operating system. I'm running Windows, I'm going to install for Windows, and then I will simply just open when done. Okay, accept the license agreement. Next. You can create a desktop icon and add to path. Next. Then install. And then give it a second, or a couple minutes. Then you can launch this if you prefer. I think I will. Okay, we are now within Visual Studio. Head to the left-hand menu for extensions. We're going to install two extensions, C/C++. That contains a telesense and a couple other useful things, so install that. And then next we will install Code Runner. Code Runner. Install. After installing these extensions, you may need to restart VS Code. Okay, then we are going to add a new folder. Go to the left-hand menu, add folder. I'll create a new folder on my desktop. So I'll right-click, go to New, Folder. I'll name this C Files. Then Add. I think you might have to click within the folder. Okay, we now have a folder named C Files. Then to create a new C file, go to New File after clicking this folder. I'll name this Hello World. And make sure that it ends with the C extension, helloworld.c. And we now have a C file that we can work with. And on this tab at the top, this says helloworld.c. Now the next thing that we'll need is that GCC compiler to convert C code to machine code. Now if you're running Windows, this is how to check to see if you have a GCC compiler already installed. So you're going to open Command Prompt and enter this command, G++ -- version. I already have a GCC compiler already installed. If you're getting an error, then you'll probably have to download one. Here's an interruption from Future Bro. I traveled from the future to the past to deliver you this message. So if you need to install GCC on a Mac operating system, what you're going to do within a terminal window is enter the following command: clang -- version. If clang isn't installed, enter the following command: xcode -select -- install. And that's all there is to it. If you need additional assistance, you can always visit this webpage, code.visualstudio.com/docs/cpp. And if you're running on Linux, within a terminal window, you'll enter this command instead: gcc-v. If GCC isn't installed, run this command: sudo apt-get update. And then next type in this. And that's all. What you're going for our C++ to see if we'll have a C file that we can work with. And on this tab at the top, this says helloworld.c. Now the next thing that we'll need is that GCC compiler to convert C code to machine code. Now if you're running Windows, this is how to check to see if you have a GCC compiler already installed. So you're going to open command prompt and enter this command: g++. I traveled from C, enter the following command: clang -- version. If clang isn't installed, enter the following command: xcode -w6 on that. Load should change. GCC underneath Advanced tab. Edit. I already have this. Edit. Okay. Configure default build tab. Configure default JSON file coding. Let's try maybe. I also recommend enabling autosave. That's going to save you a lot of headaches later in the future. So go to File, Autosave. Okay, the first thing that we're going to include within our C program is the word #include. So this is a preprocessor command that tells the compiler to include the contents of a file, and the file that we would like to include is within angle brackets std for standard io input output.h. This file contains some useful functions related to input and output, so we'll need that. Now the entry point of our program is the main function. Type int main parentheses curly braces. Anything within our main function is read procedurally, starting from the top and working its way down. So anything within this set of curly braces is within the main function. And at the end of our main function, we're going to add this statement: return 0 semicolon. A semicolon is used to terminate statements, kind of like a period at the end of a sentence. At the end of our main function, we have this return 0 statement. This returns the exit status of our program. We return a 0 if our program runs successfully with no errors. If there is an error, then we'll return a 1. So now we can add anything that we want within this main function, but we'll need return 0 at the end to check for any errors. So let's print something to our console as output. So to display something, we're going to type printf parentheses semicolon, because we end our statements with a semicolon. And within the parentheses, add a set of double quotes because we would like to literally print something. And you can type in whatever you want. Let's say, I like pizza. Then to run this code, you can either right-click, then go to Run Code. Alternatively, there is a Run Code button in the top right corner of VS Code. So after running this code, this displays my output: I like pizza. So what if I would like to add a second line? Well, I would just follow these steps again. So I need another printf statement, printf parentheses semicolon. Any text I would like to display, I'll place that within a set of double quotes. This time, let's add a second line. I like pizza. It's really good. And then save. Alright, and this is what this looks like. I like pizza. It's really good. So this is all one long line. What if I would like my second line of text on the next line? Well, I can add an escape sequence for a new line character. So at the end of my printf statement, within the double quotes, I'll add \n for a new line character. And let's try that again. So I'm going to clear my output, make sure I save, and then run this again. I like pizza, it's really good. And then we have that extra space at the bottom because we added an additional new line character, which is optional. Also, take notice too that we have this message exited with code equals 0. So if there are no errors and your program runs successfully, this function will return 0. If there is an error, well then this will return 1. So let's misspell something. Let's say instead of printf, we just have print. So save and then run this again. Okay, it looks like we have an error. Exited with code equals 1. Alright people, well, that's your first C program. In the next video, we'll cover escape sequences and comments. I'll post this code to the comments section down below and pin it to the top if you would like a copy for yourself. But yeah, that is your first C program. Hey you, yeah, I'm talking to you. If you learned something new, then help me help you in 3 easy steps by smashing that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Alright everybody, welcome back. In this video I'm going to show you all how we can compile and run a C program using command prompt. In my text editor I have a simple C program that prints I love pizza, it's really good. What we'll need to do is open command prompt. Now before we begin we should make sure that we have a GCC compiler, and to check that just type gcc -- version. And it looks like I have one, so if you're missing a GCC compiler, check the first video in this series and I'll show you how to download one. Now, step 1 to compiling a C file is that we need to change our active working directory so that it's pointing to the folder containing our C file. An easy way to change that is that we need the file location. So I'm going to right click on my C file, go to Properties, copy this location, and within command prompt I will type cd to change directory, and then paste that location. So our current active directory is pointing to that folder containing our C file, and to compile a C file, you type gcc, the name of the file, and mine is helloworld.c, then hit enter. So nothing appears to happen, and that's good. So let's take a look at the C folder again. This is the file that we compiled. It is an executable, and all we have to do is run that. So that is the third step, a.exe, enter. I love pizza, it's really good. So yeah, that's how to compile and run a C file in command prompt. First, make sure that you have a GCC compiler. That would be, I guess, step 0. Step 1 is to change the active working directory to the folder containing your C file. Compile the C file with gcc, the name of the file, and then run the compiled file, a.exe. So yeah, that is how to compile and run a C file with command prompt. If you found this video helpful, please be sure to smash that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to explain both comments and escape sequences in C. So sit back, relax, and enjoy the show. Alright, welcome back. So we have to discuss comments and escape sequences. So a comment is some text that is ignored by the compiler that is used as an explanation, description, or a note for yourself or anyone else reading over your code. So to write a comment, you will type 2 /, then anything afterwards is considered a comment and will be ignored by the compiler. This is a comment. Blah. So if I was to run this text will be ignored by the compiler, and we do not see that as output. I tend to use a lot of comments when explaining things, so this is something you'll see fairly often in my videos. Now, if you need a multi-line comment, this is only for a single line comment. If I was to type this again without those /, this is a comment. Well, our program thinks that this is some sort of code. If we need a multi-line comment, you will instead type /*, then anything after is considered a comment. You can see that this is all green now. Anything up to a asterisk and / will be a multi-line comment. This is a multi-line comment. And again, this is ignored by the compiler. So if you need to write a note, description, or explanation for yourself or for somebody else, you can write that within a single line comment or a multi-line comment. And I use a lot of these for teaching purposes because I have a lot of explaining to do, right? Okay, let's move on to part 2 of this video. We have escape sequences. An escape sequence is a character combination consisting of a backslash followed by a letter or combination of digits. They specify actions within a line of text, otherwise known as a string. So we learned in the last video that we can end our printf statement with a \n to create a new line. This is the escape sequence for a new line. And within a string of text, a line of text, and within a string of text, we can add a new line wherever we want and as many as we want. Let's say that after each word within my line of text, I would like to add each word to a new line. So I can use the escape sequence for new line after each of these words. So that would look like this. I like pizza. But you may have to work on the spacing though. That's a little bit better. So wherever you place a \n, that will create a new line character. Another escape sequence is \t for a tab. So let's say I have a few numbers here, 1, 2, 3, and I would like to create even spacing between these numbers. I can just add an escape sequence for a tab character. 1, \t, 2, \t, and these numbers are spaced evenly. Or I can get really fancy and add a new line character, then maybe a 4, tab, 5, tab, 6, new line character, then maybe a 7, tab, 8, tab, and then a 9. So now we have a grid of numbers all spaced evenly. So that is the new line escape sequence and the tab escape sequence. You can use them wherever and however many you want within a string of text within a printf statement. What if we need to display quotes like we're quoting somebody? I like pizza. This is a quote from Abraham Lincoln, probably. I need to place quotes around I and pizza. So if I were to write it like that, well, our program doesn't know where our string of text begins and ends. It's kind of confused. If we need to literally print double quotes, we will add an escape sequence, \, then double quote, and then add that here as well. So this allows us to literally print some quotes as output. I like pizza, Abraham Lincoln, probably. Or if you need to display single quotes, \, single quotes. So that's how to display single quotes. And if you need to display a \, that would be double backslashes. This will literally print backslashes. So yeah, those are just a few escape sequences. Here's a list of a bunch of them, but a lot of these really aren't going to be relevant to us. So yeah, those are comments and escape sequences in C. If you found this video helpful, please be sure to destroy that like button, drop a random comment down below, and subscribe if you'd like to become a fellow bro. Hey, it's your bro, hope you're doing well, and yeah, we're doing stuff with variables today in C, so sit back, relax, and well, enjoy the show. Welcome back to another video. So, variables. Variables are allocated space and memory to store a value. We refer to a variable's name to access the stored value. That variable now behaves as if it was the value that it contains. But to create a variable, we first need to declare a name for a variable and then precede it with the type of data that we are storing. Creating a variable is done in 2 steps, declaration and initialization. So we need to first declare a variable to allocate some space and memory to store a value. So we need to precede our variable name with the data type of what we plan on storing within this variable. If I need to store a whole integer, we would precede our variable name with int for integer. And let's say that this is variable x. So this step is declaration. We are creating space and memory to store a value. And to actually store a value, that step is initialization. So we would take our variable name, x in this example, and set it equal to some value. So we declared that this variable is an integer. We can only store whole integers, maybe the number 1, 2, 3. So this is initialization, or you could combine these steps together, and let's create int y. Int y equals 321. This is both declaration and initialization. So creating and storing a variable takes two steps, declaration and initialization. And in order to create a variable, you have to precede the variable name with the data type of what you plan on storing within that variable. Int for a whole integer, but there's other data types too. Let's create some more variables. What about int age? With variable names, you're not limited to only just x and y. You can really name it whatever you want within some limitations, but make sure that the variable name is descriptive of what it does. So age is going to store an age. Let's say that I am 21 years old. So this is an integer, a whole number. If we need a number containing a decimal portion, that would be a float for floating point number. So one example of a variable that could contain a floating point number is a GPA, grade point average. Let's say that my grade point average is a 2.05. So this is a floating point number. It's a number that contains a decimal portion. We can also store single characters with the char data type, like you're pronouncing Charizard, and this will be a letter grade, let's say. Now to store a single character, we have to place it within single quotes when we initialize it. With my grade variable, what about a C? Like my average grade is a C. Remember everybody, C's get degrees, so char stores a single character. Now, C isn't an object-oriented language, so there is no string data type because strings are technically objects. So if we would like to store like somebody's name, we need a series of characters. So we can create what is called an array. And to create an array, we would follow our variable name with a set of square brackets, and then assign this equal to some string of text, some series of characters. Place your series of characters within double quotes, and we can store more than one character. So this data type would be technically an array of characters. I'll create a whole separate video on arrays. This is basically how you can emulate a string. It's really just a whole combination of single characters. There's still a lot more data types than just these four. I thought I would cover just some of the more basic data types, just because in this video we're going to focus more on variables than data types. I'm planning a separate video just dedicated to data types because there's way more data types than just these four. There's bytes, there's doubles, there's longs, etc. Now, how can we display the value stored within a variable within a printf statement? Here's how. We have to use what is referred to as a format specifier. Let's say we have a printf statement, and I would like to display my age within a message. So let's create some text. You are age years old. If I would like to display the value contained within my age variable, wherever I would like to insert that value, I will place a format specifier which is represented by a %, and then follow this with a secret character that represents the data type of what we're inserting. So if I need to display my age variable, I will use a % as a placeholder, followed by D for decimal. And then after my string of text, outside of the double quotes, add comma, then the name of the variable you would like to insert at this placeholder. So at this location, I will insert age. And then let's try this. You are 21 years old. So let's try that again with a different variable. Let's go with name. I'll add a second printf statement. Printf. And then let's say hello. And I would like to insert my name here. So use a % as a placeholder. It's a format specifier. Then to display a character array, that would be S for string. And then add comma, name. Oh, then we may need to add a new line character to the end of these because I forgot. Let's try that again. Hello, bro. You are 21 years old. Okay, let's display our grade. Printf. Then within quotes, your average grade is, then to display a character variable, that would be %C for character. Then outside of our double quotes, add comma, the name of the variable we would like to insert at this location. So comma, grade. I think I'm just going to space these out a little bit. Okay, then I will add a new line character to the end of this. Okay, hello bro, you are 21 years old. Your average grade is C. Then to display a float, that would be %F. Print F. Your GPA is %F. Then I'll add a new line character. So follow this with comma, the name of the variable, GPA. Okay, your GPA is 2.05. So later on, we'll discuss more about format specifiers. There's ways that we can format how our variables are displayed. I just realized that I misspelled average twice. So yeah, those are variables. They are allocated space and memory to store a value. We refer to a variable's name to access the stored value. That variable now behaves as if it was the value that it contains. But to declare a variable, we have to state what type of data that we are storing within that variable. So yeah, those are variables. If this video helped you out, help me out by smashing that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Alright, what's going on people? Let's discuss more about data types. We discussed a few in the last video, but there's a few more that you should be made aware of. So chars, they store a single character and use the %C format specifier to display a single character. There's an array of characters which can store one or more characters. Then to display that, you use %S as the format specifier. Floats, they will store a decimal number, and we use the %F format specifier to display a floating point number. And then we have integers which only store a whole integer. There's no decimal portion, and we use %D to display an integer. Now along with floats, we have doubles. Doubles have double the precision of a float. We can store even more significant digits. Floats use 4 bytes of memory. They have 32 bits of precision, and we can store between 6 to 7 significant digits. Doubles, they have 8 bytes of memory, double that of floats. And they have 64 bits of precision, and we can store between 15 to 16 significant digits. With my float and my double, I'm storing the first several digits of pi. I'm going to attempt to display as many digits of pi as I can with a float. So I'm going to display these. So to display a float, use %F and LF for a double, which means long float. Now by default, when I use printf to display a floating point number or a double, this will only display the first 6 to 7 digits, but we can actually change that. We'll discuss more about these in the next video on format specifiers. If I would like to display even more digits, after the decimal I will add 0 point and the amount of digits I would like to display. So I would like to display 15 digits after my decimal, and I'll do that for my double as well. So after the % sign, 0.1f, then add LF. And let's take a look at these numbers. Okay, after my 2, which is, I believe, the 6th digit after the decimal, we actually lose our precision. These numbers are not the same, but our double will actually retain these numbers. So point being, a double is even more accurate than a floating point number. There is more precision, but it uses more memory. A double uses 8 bytes of memory. Because of this reason, we tend to use doubles a lot more than floats just because they're more precise. We don't want to lose our precision. Next up, we have booleans. To work with booleans in C, include this at the top, stdbool.h. Booleans store true or false. So they work in binary. 1 represents true and 0 represents false. So when you need to declare a boolean variable, you type bool, then a variable name, and you set it equal to true or false. Technically, we only need 1 bit to represent true or false, 1 for true and 0 for false, but this still uses up 1 byte of memory. And then to display a boolean, you can use %d. So if I was to display this boolean variable, I would use %d. So 1 corresponds to true, and 0 corresponds to false. Although there are some tricks that we can do in the future where we could display the word true or the word false. But for now, we're going to stick with %d as the format specifier. So these work in binary, 1 for true, 0 for false. Now another thing that we can do with chars is that we can store a whole integer between the range of -128 to +127. So in this example, we have char f, and I will store the integer number 100. We can display this number as either a decimal, an integer, or a character. So if I was to display this number as a character, we will use the ASCII table to convert this number to a character representation. The ASCII table has a range between 0 to 127, so if I was to display this number as a decimal using the %d format specifier, of course this will display as 100, but if I was to convert this to a character using the %c format specifier, this has a corresponding character, and that would be lowercase d. So I'm actually going to change this to something else. What about, I don't know, 120? So let's see what the character representation of that number is, and that would be a lowercase x. So you can use chars to store more than single characters. You can also use them to store a whole integer. However, the range is between -128 to +127 because they have 1 byte of memory. Now there is a keyword unsigned. So when you declare a variable that is unsigned, we disregard any negative numbers. So effectively this doubles our range with our positive numbers. So if we have unsigned char, we can store a number between 0 to +255 because we know we're not going to store a negative number. So then if you need to display an unsigned character, we can use just %d. I'm going to store 255 within my unsigned char, and that would be, of course, 255. However, if we go beyond this range, this will overflow and go back to 0. So if I was to display this, we have a warning. Unsigned conversion from int to unsigned char. So then this resets back to 0. So if you go beyond the maximum range, this will reset all the way back to 0, whatever the beginning is. So if you add this keyword unsigned, you can effectively double the range of positive numbers that you can store within a variable. By default, most data types are already signed, but we don't need to explicitly type that. So point being, with chars, you can store more than a single character. You can store a whole integer between ranges -128 to +127 if it's signed. If it's unsigned, you can store numbers between 0 to 255. You can display them as an integer by using the %d format specifier, or you could convert them to a character using the ASCII table by using the %c format specifier. Next we have short ints. Short ints use 2 bytes of memory. They can store a number between -32,768 to +32,767 because, well, they use 2 bytes of memory. They can only store a number so large, and if it's an unsigned short int, the range is instead between 0 to 65,535. And we use the %d format specifier to display a short int. So within my printf statement, I'm going to display these two numbers. So I will display variable h and I. H is a short integer, and I is an unsigned short integer. So these are the maximum values for a short integer and an unsigned short integer. And like I discussed with chars, if we go beyond this range, we will encounter an overflow. So I'm going to change this short int to 32,768. And let's see what number displays. So this will overflow and reset this value back to the minimum value, which in this case is -32,768. And if you do the same thing with the unsigned short integer, that would be 0 because that's the minimum value for an unsigned short integer. So those are short integers. They use 2 bytes of memory, and they can store numbers between these ranges, depending if it's signed or unsigned. Oh, and another way of writing these, you don't necessarily need to declare these with the word int. You could just say short, and that would do the same thing. People usually just call them shorts instead of short ints. So those are what shorts are. Now with integers, we kind of discussed this in the last video just briefly. Integers store a whole number between just under -2 billion to just over +2 billion because they use 4 bytes of memory, and we use the %d format specifier to display a signed integer. If that integer is unsigned, the range changes from 0 to just over +4 billion. However, there is a different format specifier. To display an unsigned integer, you instead use %u. So then let's display these. %d for a signed integer and %u for an unsigned integer. And these are the maximum numbers. And then if I was to exceed the range, this again would cause an overflow and reset these numbers back to their minimum values. So those are standard integers. They use 4 bytes of memory, so they can store numbers between these ranges depending if they're signed or unsigned. Alright, the last data type we're going to talk about for this topic is a long integer. Now the reason that we have long twice is that with standard integers, these are already considered longs, but we don't need to explicitly type long for standard integers. So to represent a really large number, we can use a long integer. And these use 8 bytes of memory. The effective range for a signed long integer is just underneath 9 quintillion to just over 9 quintillion. And the format specifier for a long integer, one that is signed, is %LLD. Now, if it's unsigned, that changes the range between 0 to just over positive 18 quintillion, and the format specifier is %LLU. Then let's display these. So, for a signed long integer, that is LLD, and if it's unsigned, that is LLU. Now, we'll encounter a warning. So this warning applies to our unsigned long integer. Integer constant is so large that it is unsigned. So one way in which we can prevent that warning is after our number within our unsigned long integer, add a u to the end of this. So then we can display this number with no warning. So since long integers use so many bytes, they can store a gigantic number. We tend to not use long integers very often because, well, we don't really have a need for this large of a number. But in certain circumstances you might. Perhaps you're dealing with the speed of light or something. You may need to use a long integer. But commonly we use standard integers a lot more. Well, yeah, everybody, those are even more C data types. We likely won't be using most of these, but you should still be made aware of their existence. I would say that we're going to focus on chars, array of chars, doubles, booleans, and integers. So pay attention to those ones, but you should still be made aware of the existence of other data types just in case you encounter them. If you found this video helpful, please smash that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Alright, welcome back everybody. In this video I'm going to show you all a few extra things that we can do with format specifiers. Using a format specifier within a printf statement, we can define and format a type of data to be displayed. To use a format specifier, you use a %sign, then follow that %sign with a certain character depending on the type of data you would like to display. Let's say that we have 3 variables. Maybe we have an online store or something like that. So let's say that these are of the float data type, and we'll have 3 items for sale. Item 1, and make up some price. Let's say that the first item is $5.75. And we have item 2, and this will be $10 even, and then we have item 3, and this will be $100.99. So let's display item 1, item 2, and item 3 with a printf statement. Printf, and within a string, let's say item 1, colon, space, then I'll add a $sign. Wherever you would like to insert a value or variable, you will use that format specifier, the %sign. So after my $sign, I'll add item 1. So that would be %, then for floats you need f. And then after the string, add comma, item 1. Then let's just make sure that this works. So we're going to be formatting this output. What if we don't want all the zeros? We can set the decimal precision of a float or double. After the format specifier, add a dot and the amount of digits you would like to display. If I would only like to display 2 digits, after the %, I will add 0.2. And this will only display 2 digits for the amount of cents that we owe. Okay, now let's do the same thing for items 2 and 3. So item 2, item 2, item 3, item 3. Okay, then let's add a new line character because I forgot. So new line, and new line. Much better. Another thing that we can do with format specifiers is that we can set a minimum field width. So just add a number after the %sign. Let's say that I would like to allocate 8 spaces worth of room to display my number. So after the %sign, but before the decimal, add how many spaces you would like to set for the minimum field width. Let's say 8. And let's see the new output. Okay, there we go. However, it's all right aligned. If you would like this left aligned, you would use a negative sign after the %. To left align all of this, this would be negative whatever number you would like to allocate. So the number is left justified, but we still have all of this room after. So that's what a format specifier is. It defines and formats a type of data to be displayed. So place a format specifier within a string, use a certain character for the type of data you would like to display. You can set decimal precision for floats and doubles. You can set a minimum field width to display your output if you would like to line things up like you can see here. And you can left or right align your output. So yeah, those are format specifiers. If you found this video helpful, please be sure to smash that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey everyone, so I'm going to attempt to explain constants in about a minute. A constant is a fixed value that cannot be altered by the program during its execution. I have a variable pi. Pi equals 3.14159. But what if we accidentally or somebody else changes the value of pi? It's an important number. Pi now equals 420.69. Since this value was changed, this will alter the result of our program. To prevent a variable or value from being changed, we can turn that variable into a constant by preceding the data type with this keyword const. And a common naming convention with constants is that you make all of the letters uppercase, although it's not necessary, but it's considered good practice. So if I attempt to take our constant and assign this a different value, we'll run into an error. Assignment of read-only variable pi. That is what a constant is. It's a fixed value that cannot be altered by the program during its execution, and it provides a little bit of security. So if you found this video helpful, please be sure to smash that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Well, welcome back. So we need to talk about arithmetic operators because, well, this wouldn't be a full course without them. So as you probably know, arithmetic operators are, well, addition, subtraction, multiplication, division, and there's a few others too unique with programming, such as modulus, increment, and decrement. So let's go over a few. Let's say that we have int z, and if we need to add two numbers, we could say x plus y equals z, and then display the sum, which of course is 7. So subtraction is, well, minus. 5 minus 2 is 3. Multiplication is an asterisk. 5 times 2 equals 10. Okay, now pay attention to this with division. So 5 divided by 2 equals 2.5, right? Well, that's where you're wrong. It's 2, because we're storing the result within an integer, and with integers we can only store whole numbers. So we will lose that decimal portion. It will be truncated. There's a few things we'll need to change. First, we'll need to store the result within a float or a double. And then let's display this. %f for a float. Okay, another thing that we need to change too. And that involves integer division. If we're dividing by an integer, we'll truncate that decimal portion. There's one of two things we can do. We can either change our divisor to a float or a double, and that will solve that problem, 2.5. Or if we would like to keep this as an integer, we can convert this integer to a float or double by preceding the divisor with float or double, either one. So if I would like to keep y as an integer and we divide x by y, we will convert 2 into a float, so 2.0. and store the result within float z, and the result is 2.5. So if you're performing division with any integers, you need to pay attention to integer division, and you may need to cast your divisor as a float or as a double. Now we have modulus. Modulus gives you the remainder of any division. 5 does not divide by 2 evenly. Int z equals x modulus y. And if we display z, so make sure to change your format specifier if you didn't, the remainder of 5 divided by 2 is 1. If this was 4, 4 divides by 2 evenly, and the result is going to be 0. Modulus gives you the remainder of any division. It's actually pretty helpful to find if a number is even or odd. All you do is say modulus 2, or some variable containing the value of 2, either way. And then we can increment or decrement a number by 1. If I need to increment x for some reason, you'll see this when we get to the video on loops. I could say x plus plus, and then let's display x. X incremented by 1 would be 6. And then let's decrement y. Y minus minus. And y decremented by 1 equals 1. So, yeah everybody, those are a few arithmetic operators. A lot of these are fairly simple. You know, addition, subtraction, multiplication, and division. Do pay attention to integer division because that can throw off your program. Then there's also modulus, increment, and decrement. If you found this video helpful, please remember to smash that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey, welcome back everybody. Here's a super quick video on augmented assignment operators. They're used to replace a statement where an operator takes a variable as one of its arguments and then assigns the result back to the same variable. Now what the heck does that mean? Okay, so let's say that we need to increment the value of x by 1. Without using an increment operator, we could say x equals x plus 1. So writing this out can be somewhat redundant. There is a shortcut by using an augmented assignment operator. Whatever variable you would like to perform an operation on, you will list that variable, use an arithmetic operator, equals, and then some value. So writing this would increment x by 1. So let's go over a few examples. We have int x equals 10. So I could write x equals x plus 2 to increment x by 2, right? Or I could say, as a shortcut, x plus equals 2, and that will do the same thing. And that's 12. Now let's try minus. X equals x minus 3. Using the augmented assignment operator, that would be x minus equals 3, which is 7. What about x equals x times 4? Well, that would be x times equals 4. X times 4 is 40. And division. X equals x divided by 5. The augmented assignment operator of this equation is x divided by equals 5, which is 2. And lastly, modulus. So what about x equals x modulus 2? That would be x modulus equals 2. X modulus 2 equals 0. Well, yeah, everybody, those are augmented assignment operators. They're basically a shortcut. They're used to replace a statement where an operator takes a variable as one of its arguments and then assigns the result back to the same variable. It's a shortcut. If this video helped you out, you can help me out by smashing that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey, welcome back. In this video, I'm going to show you all how we can accept user input in C. Now, if you're using VS Code, we need to switch from using our Output tab to Terminal. And one way in which we can make that change is by going to File, Preferences, Settings, search for Code Runner, and then check this, Run in Terminal. So then when we run our code, it will now display in Terminal, which accepts user input. Output doesn't because, well, it's only for output. And you can ignore this. This is a PowerShell command that will compile and run your C program. But if you prefer, instead of PowerShell, you can use Command Prompt. But you would need to manually compile and run your code. Since I'm using Windows, that would be a GCC, the name of your C program, helloworld.c. That will compile your program into an executable named a.exe. Then just type that to run it. But I'll stick with using PowerShell just to kind of simplify things. Okay, now how can we accept user input? Let's declare a variable age but not yet assign it. Next, we're going to create a prompt to ask the user for their age. And we'll ask, how old are you? To accept user input, we can use the scanf function. It's kind of the inverse of printf. Printf is used to display something as output. Scanf is used to read input. What we're going to place within our scanf function is the format specifier of the variable we will insert a value into. If we need to accept a number, an integer, as input, the corresponding format specifier is %d. Then add a comma, the name of the variable, but precede the variable name with an ampersand. That is the address of operator. Let's print a message that contains the value stored within our variable age. You are %d years old. So this is our format specifier. It functions as a placeholder, and I would like to display the value contained within my age variable. So things are getting a little bit difficult to read. I'm just going to precede this with a new line. Okay, let's try that again. How old are you? Let's say that I'm 21. Not anymore, but let's pretend that I still am. You are 21 years old. That's basically how to accept user input. You use the scanf function, Use the format specifier of the variable. List the variable preceded with the address of operator. Let's try this again, but instead accept a string from a user like a name. We need to declare an array of characters and set a size. So let's create a character array named name. Now with character arrays, we can't change the size of the array after the program is already running. Let's set a max size of maybe 25 bytes for this array. If we go over this limit, this will cause a buffer overflow. And let's ask a user for their name. So we'll create a prompt, printf, what's your name? And I again will use scanf, list the appropriate format specifier for character arrays, which is %s, then our variable name, and use the address of operator. Then at the end, we'll display our name. Printf, hello, %s, how are you? Then comma, name. And before we run this, I'm just going to add some new line characters, just to make everything easier to read. Okay, let's try it. What's your name? I'll type in just my first name, not including any white spaces. How old are you? 21. Hello, bro. How are you? You are 21 years old. So now, this time, let's type in a first and last name, because this is going to act a little bit bizarre. What's your name? Bro, code. And this is separated with a white space. Hit enter. Hello, bro. It did not include my last name. How are you? You are 0 years old. So using the scanf function, we will read up to any white spaces. So if your user input is going to include a white space, we need to use a different function, and that is the fgets function. Fgets, parentheses, and there are three things we will list within the fgets function. The name of the variable, and we do not need the address of operator, that ampersand, for this. Then we need to set an input size. I will set this to 25 to match the size of our array. And then stdin, which means standard input. So using this function, we can read any white spaces. What's your name? I'll type in a first name and a last name. How old are you? 21. Hello, bro code. And notice that our output is actually being displayed on the next line. That's because when you use the fgets function, it will include the new line character when you hit enter. If you need to get rid of that new line character at the end so that it's not included with your input, here's what we can do. It's a little advanced, but we'll cover this in future videos. We'll include this import, include string.h. So using this import, we can work with strings. All we're going to do is edit our string and get rid of that new line character at the end. What I'm about to show you will look a little bit advanced, but it's going to make more sense when we get to the video on string functions. Type the name of the variable, followed by a set of straight brackets. Type strlen. This gets the length, subtract 1, and we will set this equal to \0. That will get rid of the new line character. So again, this is a little bit advanced for us, but it'll make more sense in future videos when we get to the video on string functions. And let's try this one last time. What's your name? Type in a first name and a last name, hit enter. How old are you? 21. Hello, bro code. How are you? You are 21 years old. If you need to accept a string from a user that includes white spaces, like a first name and a last name, you'll want to use fgets in place of scanf, because scanf can't read those white spaces. It stops right there. But it will include that new line character when you hit enter. So you can do some string formatting just to get rid of that new line character. And like I said, this statement here will make more sense when we reach the video on string functions. But yeah, basically that's how you can accept user input. You can use the scanf function. If you need to accept a string of characters that includes white spaces, you want to use fgets instead. So yeah, that's how to accept user input in C. If you found this video helpful, please be sure to smash that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey, what's going on everybody? So in this video I'm going to show you some useful math functions in C. Now if we include this math header file, this contains a lot of the useful functions I'm about to show you. One useful function is the square root function. Let's say that we have a bunch of variables. We declared them, but we have not yet assigned them. I will assign A the square root of 9. So after including this math header file, I have access to a square root function. So type sqrt, then add a set of parentheses, and within the parentheses we can find the square root of a number. Let's find what the square root of 9 is, and then display it with a printf statement. So the square root of 9 is 3. So let's move on. We can raise a base to a given power by using the pow function. The first number is the base. Let's raise 2 to the power of 4, and then display it. 2 to the power of 4 is 16. We can round a number, and I will store this within an integer. Let's round 3.14. Oh, and then make sure you use the appropriate format specifier for ints. 3.14 rounded is 3. Now by using the ceil, short for ceiling function, we can always round a number up. 3.14 rounded up is 4. Likewise, there's a floor function where we will always round down. 3.99 rounded down is 3. We can find the absolute value of a number. That's how far a number is away from 0. So it will take any negative numbers and make them positive. The absolute value of negative 100, and that would be positive 100. If you're familiar with logarithms, we can find the logarithm of a number. Log 3 is 1.098612, and if you know some trigonometry, there's various functions for sine, cosine, and tangent. So what's the tangent of 45? That is supposedly this number, 1.619775. So yeah, everybody, those are a few math functions that you might be interested in. To use these, just include this header file at the top, math.h. If you found this video helpful, please be sure to smash that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey everyone, here's a quick program that we can make to calculate the circumference of a circle. I thought this would be good practice for us now that we know how user input works. Let's declare all of the variables that we'll need. I'm going to create a constant variable named pi, and it's going to be of the double data type. Pi equals 3.14159. The reason that I'm making this a constant, smash that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey everyone, here's a quick program that we can make to calculate the circumference of a circle. I thought this would be good practice for us now that we know how user input works. Let's declare all of the variables that we'll need. I'm going to create a constant variable named pi, and it's going to be of the double data type. Pi equals 3.14159. The reason that I'm making this a constant is that I don't want anybody else to be able to change the value of pi. And let's declare, but not assign, a radius quite yet. We'll have the user type that in. And double circumference. This will be calculated and displayed. So we will need to prompt the user to enter in a radius. I'll precede this with a new line. Enter radius of a circle. And then I will use scanf to accept some user input. We need to list the format specifier of doubles, which is LF, comma, address of operator, radius. Then the formula for radius is 2 times pi times radius. And then we will display our circumference using printf. Circumference. Then we need a format specifier. We're displaying a double, so the format specifier is LF, comma, circumference. And let's run it. Enter, well, the radius of a circle. Let's say that our radius is 10. Maybe this is 10, I don't know, meters. Alright, our circumference is 62.83 meters. Now why not take this a step further? Let's also calculate the area of a circle. I wasn't planning on taking it this far, but hey, let's calculate that as well for practice. So let's declare a double variable named area, and we will calculate what area is. The formula for the area of a circle is pi times radius squared. Pi times radius times radius. Then let's display the area. So area, we're using the double format specifier and area. Then let's add some new line characters to separate everything. Enter the radius of a circle. Let's say 10 meters. The circumference is 62.83 meters, and the area is 314.15 meters. Alright everybody, that is a small program to calculate the circumference of a circle, and I guess the area as well, just because, well, why not? So yeah, if you found this video helpful, please be sure to smash that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Alright, welcome back everybody. In this video we're going to write a small practice program to find the hypotenuse of a right triangle. We'll need the help of our math.h header file because we'll need access to some useful math functions. More specifically, the square root function. Let's declare all of the variables that we'll need. We'll need sides A, B, and C. And these will be of the double data type. A, B, C. We'll ask the user to enter in sides A and B. Printf, enter side A, and then we will use scanf. So the format specifier for a double is LF. Then I would like to insert a value within A, so I need to use the address of operator, then our variable A. Okay, let's do the same thing for side B. Enter side B, and store the user input within variable B. The formula to find the hypotenuse of a right triangle is the square root of a squared plus b squared. So we will set c equal to the square root function, and within the parentheses, we will say a times a plus b times b. And then we will display c. Side C. And the format specifier for a double is LF. And we are displaying C. And, well, let's try it. So side A, let's say, is 3, side B is 4. That means side C is 5. So, yeah, I thought that would be a good practice program for us to get used to accepting user input. If this video helped you out, help me out by smashing that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey, let's talk about if statements. If statements are used to add some choices to a program. Let's take the small program for example. We have a variable age, and we'll ask a user to enter in their age. What if I would like to check their age? Maybe they're signing up for a credit card or something. So to check some value, we can write an if statement. If, parentheses, then a set of curly braces. If some condition that we specify is true, we will execute some block of code, some subsection of code. What sort of condition should we write? Let's check to see if age is greater than or equal to 18. So there's different comparison operators. There's greater than or equal to, greater than, less than or equal to. Or you could check to see if two values are equal by using double equal signs. This is the comparison operator. If you use just one, this is the assignment operator. And this would be the same as assigning age equal to 18. So if you need to compare if two values are equal, use the comparison operator, which is double equal signs. But what I would like to do is check to see if age is greater than or equal to 18. If this condition evaluates to be true, we will have our program do something. So let's print a message. Since we're signing up for a credit card, let's say you are now signed up. And let's run it. Enter your age. Let's say that I'm 21, I hit enter, boom, you are now signed up. But what if this condition is false? Let's say that I'm 12 years old and I'm attempting to sign up for a credit card. Well, we skip this if statement. If this condition evaluates to be false, we will skip this block of code and continue on with the rest of the program, ignoring it. Or we could do something else by using an else statement. If this condition is false, we will skip this subset of code and instead perform this. Let's print a different message instead. You are too young to sign up. And let's try that again. Enter your age, I am 12. You are too young to sign up. You can check more than one condition before reaching your else statement by using else if blocks. and that is by using else-if statements. We can check another statement before reaching our else statement. So let's check to see if age is less than 0. So obviously somebody's messing with this program then, because you can't be under 0 years old, right? You haven't been born yet. So after running this program, if I say that I'm -6, you haven't been born yet. So we will check our if statement first. If this condition is false, we will move down to the next block, and then check this else if condition. If all above statements evaluate to be false, we will execute this else block as a last resort, so to say. And with these else if blocks, you can add more than one. Let's check something else, just to demonstrate. Else if, what about age is equal to 0? And we will print, you can't sign up. You were just born. Enter your age, I am 0 years old. You can't sign up, you were just born. If one of these conditions evaluates to be true, we will skip all of these statements that come after. Then with our else block, if all above statements evaluate to be false, we definitely execute whatever's within here. So yeah, those are if statements. They add some choice to a program. You can check to see if some condition is true. If not, you can check something else using else if statements. You can perform whatever is within an else block, and that's optional. So yeah, those are if statements in C. If you found this video helpful, please be sure to help me out by smashing that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Alright, welcome back people. Switches. A switch is a more efficient alternative to using many else-if statements. It allows a value to be tested for equality against many cases. Here's an example of where a switch would be useful. I have a small program. We will tell a user to enter in a letter grade, and depending on their grade, we will print a custom message. If grade equals A, we'll print perfect. Else if grade equals B, we'll print a different message, so on and so forth. So it's considered bad practice to use a lot of else if statements. A better alternative is to use a switch. Here's how we can create one. Type switch, parentheses, curly braces. Whatever value you would like to examine for equality placed within the parentheses. I would like to examine my grade. And now we need to write some cases. Case, and then some value you would like to test for equality. So I am comparing characters. I will write the character A, colon. Then if these values match, we will execute some subset of code, kind of like an if statement. Let's print perfect. And then add a break afterwards. Then you can add another case. So case B, you did good. Case C, you did okay. Case D, at least it's not an F. Case F, you failed. Now you can add a default case. This functions like an else statement. If no other cases match, we will execute whatever's within our default case. So that means there are no matching letter grades. So let's print, please enter only valid grades. And let's test it. Enter a letter grade. A. This will print perfect, whatever's within our matching case. Let's try it again. B, you did good. C, you did okay. D, at least it's not an F. F, you failed. And if there are no matching cases, we will execute our default case. How about W for win? Please enter only valid grades. The reason that we add breaks after each case is so we can break out of our switch and exit. Let me show you what this looks like if we do not have any breaks. Now let's say that we have a C letter grade. You did okay, at least it's not an F. You failed, please enter only valid grades. So the reason that we have breaks is to exit out of our switch. If we have a matching case and there are no breaks, we will continue executing each case that comes after. So it is important to have those breaks if you want to exit out of your switch. Well, yeah, that's a switch, everybody. It's a more efficient alternative to using many else if statements. Using a few else if statements is okay, but it's considered poor practice to use a lot of them. So yeah, those are switches. If this video helped you out, you can help me out by smashing that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey everybody, it's your bro, hope you're doing well, and in this video we're going to create a small program where the user will type in a temperature, and we can convert that temperature from Fahrenheit to Celsius, or Celsius to Fahrenheit. So sit back, relax, and enjoy the show. Now, before we begin this video, make sure that you include these two imports at the top. We'll be working with string functions, and many of them can be found within this import, ctype.h. So let's declare the variables that we'll need. Char unit. Unit will be either C for Celsius or F for Fahrenheit. And float temp, short for temperature. Let's prompt the user to enter in some user input. Print F is the temperature in F or C. And then we will accept some user input. So we will be accepting a character. So use the appropriate format specifier for characters. And we will use the address of operator, which is an ampersand, unit. And then let's use an if statement to check to see if unit is equal to the character C. Else if unit is equal to F, we will use the formula to convert Fahrenheit to Celsius. If it's C, Celsius to Fahrenheit. And we should probably add an else statement as well. Okay, let's actually test these right now. Okay, this will only be temporary. I'm going to print a message. The temp is currently in Celsius. And with Fahrenheit, the temperature is currently in Fahrenheit. So if the user did not type in C or F, well then what the heck did they type in? So within our else statement, let's yell at the user. Let's say that whatever they entered in is not valid input. So format specifier C is not a valid unit of measurement. And then we will display whatever the user typed into our unit variable. So let's test this. Is the temperature in F or C? So F, the temp is currently in F. Let's try it again. Is the temperature in F or C? C. The temp is currently in C. Okay, this time we will not type in F or C. How about the word pizza? This only accepts the first character. P is not a valid unit of measurement. Here's one situation that we may run into. C programs are case sensitive. If I type in lowercase f or lowercase c, well, technically neither of these conditions would be true. For example, if I type lowercase c, c is not a valid unit of measurement. To avoid that problem, I can take my user input and use the to upper function to make it uppercase. Or you could set these conditions to check for lowercase characters instead and use the to lower function. So let's take our unit variable and I'm going to reassign it after using the to upper function and then pass in our unit to make it uppercase. And now if I type in lowercase c or lowercase f, this user input will be made uppercase. The temp is currently in C. So this is optional, but I thought it'd be a good thing to add to this program. Now what we'll work on next, depending on the unit, there's going to be a different formula, a different calculation. Now we will need the user to enter in the current temperature. So let's begin with our if statement. If unit is equal to C, Celsius. Enter the temp in Celsius. This time we are accepting a floating point number. We will use scanf, the format specifier for floating point numbers, address of operator, temp. And then we need to calculate the new temperature after it's converted from Celsius to Fahrenheit, and we will reassign it into the same variable temp. Temp equals, and here's the formula, temp times 9 divided by 5 plus 32. And then let's print the temperature. Print F. The temp in Fahrenheit is, and I'm going to use a format specifier, %F, but I would only like to display one digit after the decimal, so I will add .1. And then we will insert our temperature, temp. Okay, let's try this. Enter the temperature in F or C. Currently, we only have the Celsius portion set up. So, C, enter the temp in Celsius. How about 0 degrees Celsius? The temp in Fahrenheit is 32.0. Okay, so we know that it's working. Let's fill out our else-if statement. Else if unit is equal to F. And let's copy some of this. Enter the temp in Fahrenheit. We will reassign our temperature variable. Temp equals, and here's the formula, temp minus 32 times 5, and we will divide all of this by 9. Then let's display the temperature in Celsius. The temp in Celsius is our format specifier, then the temp variable. Is the temperature in F or C? This time it is in Fahrenheit. Enter the temp in Fahrenheit. So 32 degrees in Fahrenheit should translate to 0 degrees Celsius, which it is. So yeah, everybody, I thought that would be a useful practice program for us to get used to accepting user input. I'll post all of this code from this program in the comment section down below if you would like a copy. So if you found this video helpful, you can help me out by smashing that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey, what's going on, everybody? I thought in this video we could create a simple calculator program in C for practice. Let's begin by declaring all of the different variables that we'll need. We'll need a character to store an operator. So are we going to add, subtract, multiply, or divide? We'll need double num1, double num2, and double result. Let's ask the user what type of operation they would like to use. Enter an operator. So we can use addition, subtraction, multiplication, or division. And we will use scanf to accept some user input. If we're accepting a character, the format specifier is C. And we will use the address of operator, the name of our variable we would like to store some user input into. Then let's accept num1, enter number 1. Then scanf, the format specifier for a double is LF. Num1. Okay, do the same thing with number 2. Replace 1 with 2. Then to examine our operator, let's use a switch. Switch, and we will examine our operator for any matching cases. Let's add a default case because I might forget to add this later. So if a user does not enter in anything that has a matching case, one of these 4 symbols, let's print a message. Let's say that our operator is not valid. Our first case will be addition. So case, addition, result equals num1 plus num2, and let's display our result. Result, and the format specifier for a double is LF. And then at the end of your case, you should break out of the switch. Then we can copy this, paste it, and then change any plus to minus. Then do the same thing with multiplication. And lastly, division. And And that is it. So let's try this. Enter an operator. I would like to add. Enter number 1, 4.20 plus 3.14. That is 7.34. And you can limit the amount of digits after the decimal that is displayed. If you would like to adjust that with the format specifier with the result, type dot, then the amount of digits you would like to display. So I'm just going to go ahead and change that real quick. Okay, so by adding 0.2 to our format specifier, this will only display 2 digits after the decimal, but you can keep it the original way if you'd like. Okay, let's subtract. So minus 4.20 minus 3.14 is 1.06. Okay, multiplication. 3.14 times 4.20 is 13.19. And lastly, division. 3.14 divided by 4.20 is 0.75. And we do have a default case if there are no matching cases. Let's type in a character besides one of these 4 symbols. How about, I don't know, a $sign? Unfortunately, we still need to enter in 2 numbers, and then this states our operator is not valid. So yeah, everybody, that is a very simple calculator program in C. If you would like a copy of all this code, I'll post a copy in the comments section down below. So this calculator can add, subtract, multiply, and divide. There are 4 cases, but you can expand upon this if you'd like. So yeah, everybody, that was a very simple calculator program in C. Hey, what's going on, people? Logical operators. There are 3 logical operators we will discuss in this series: and, or, and not. But in this video, we're going to focus on and first. The and logical operator, which is represented by 2 ampersands, checks to see if 2 or more conditions are true. Here's an example. We're going to create a program that will check to see if a given temperature falls within a range. So let's say we have a floating point number named temp. Temp short for temperature. And this will equal some number in Celsius. Let's say 25 to begin with. So using an if statement, let's check to see if temp is greater than or equal to 0. If that is true, then we will print something. The weather is good. Else, the weather is bad. Okay, so temp is 25, therefore the weather is good. Okay, what if our temperature is something extreme like 1000 degrees Celsius? So technically, this condition would still be true. The weather is actually not good, it's fairly catastrophic. So let's check to see if another condition is also true by using the and logical operator. We're checking to see if temp is greater than or equal to 0 and some other condition such as temp is less than or equal to 30. So if temp is at 1000, then the weather is bad. This condition is true, but this one is false. Using the AND logical operator, both conditions must be true in order to execute this statement. Now, if our temperature was 25 degrees, well then both conditions are true, and we will execute this statement. The weather is good. Now, you can add more than one condition. Let's throw in another variable. Let's say that we have a Boolean variable named sunny. Let's say that it's cloudy outside. Now, if we're working with Booleans, include this header file at the top, stdbool.h. Then let's add another condition, and let's check to see if sunny is equal to true. If you're checking the value of a Boolean variable, you don't necessarily have to type out equals true. You can say sunny is equal to 1, or you can just say sunny, because this would contain true or false. So this time we are checking to see if temp is greater than or equal to 0, and temp is less than or equal to 30, and sunny is true. The temp is 25, but sunny equals false. Therefore, we do not execute this statement. These first two conditions are true, but this one is false. And using the AND logical operator, all conditions must be true. Now, if I set this to be true, well then, all three of these conditions are true, and we will execute this statement. The weather is good. So yeah, that is the AND logical operator. It is represented by two ampersands. It checks to see if two or more conditions are true. And one example we used is to check to see if our temperature falls within a certain range. So yeah, that is the AND logical operator. In the next video, we will discuss the OR logical operator. So if this video helped you out, you can help me out by smashing that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey again, it's me. So we're going to talk about the OR logical operator. The OR logical operator, which is represented by two vertical bars, checks if at least one condition is true. Let's take the small program for example. It's kind of similar to the last video. So we have a variable named temp, short for temperature. We will first check if temp is less than or equal to 0. If that's true, we will print the weather is bad. Else if temp is greater than or equal to 30, the weather is bad. Else, the weather is good. So, you know, this program does work. The weather is good. But another way of writing this is that we can use the OR logical operator, and we can check to see if at least one of two or more conditions is true. So let's take this condition, get rid of this else if statement. So we will check to see if temp is less than or equal to 0, or temp is greater than or equal to 30. So if our temperature is negative 1000 degrees Celsius, then the weather is bad. This is true, but this is false. And using the OR logical operator, only one of these conditions needs to be true. If both are true, that's fine as well. Or our temperature could be positive 1000 degrees Celsius. The weather is also bad. This is false, and this is true, and only one of these conditions needs to be true. But if our temperature is 25, well, neither of these conditions are true. At least one condition needs to be true in order to execute this statement. So yeah, that is the OR logical operator. It checks to see if at least one condition is true. And you can check more than one condition by adding another set of vertical bars for the OR operator. So if you found this video helpful, please be sure to help me out by smashing that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey, let's discuss the NOT logical operator, which is represented by an exclamation point. Its purpose is to reverse the state of a condition. Let's write a small program. Let's say that we have a Boolean variable named sunny, and this will be either true or false. Let's say it's true to begin with. So to work with Boolean variables, include this header file at the top. And we will write an if-else statement to check to see if it's sunny outside, and print a custom message. So if sunny is equal to true, then we will print it's sunny outside, else it must be cloudy outside. So this does work, it's sunny outside. Another way of writing this is that we could say sunny is equal to 1 because true represents 1, false represents 0. This would also work. Or you could just say sunny. This would work as well. So by using the not logical operator, this will reverse the state of condition. By using the not logical operator, we're checking to see if something is not true. So if I try this again, this program states it's cloudy outside. So I think it would be better if we were to switch these print statements around. Now what we're checking is if it's not sunny. If it's not sunny, then we will print it's cloudy outside. Else, it's sunny outside. It is sunny outside. And if I change this to be false, well then, it's cloudy outside. So yeah, that's the not logical operator. You can just precede a condition or a Boolean variable with the not logical operator. And that gives you a few more options in the way in which you can write a program. So yeah, that is the not logical operator. If you found this video helpful, you can help me out by smashing that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey, what's going on? Let's talk about functions. A function is a small section of code that is executed whenever we call it, also known as invoking a function. When we compile and run a C program, we begin with invoking the main function. So here's our task. We need to sing 3 verses of Happy Birthday for some reason. If we are only using the main function, we could write it like this. This will be the first verse of Happy Birthday, and if I need to sing 3 verses, I could just copy and paste this one section, and then paste it 2 additional times. Then I'm just going to add a new line character at the end. Technically this would work, but it's considered poor practice to repeat code more than once if you don't have to. Wouldn't it be better if we write this code once and then simply reuse it? Well, we can by using a function. So let's delete 2 of these verses, and we will create a new function. So outside of the main function, let's declare a new function. So for now, we're going to type void and then a unique name for this function. Let's say that it's the birthday function, followed by a set of parentheses and then a set of curly braces. So I'm going to take any code I would like to repeat and place it within this new birthday function. And if I need to invoke this function, all I have to do is type the name of the function, followed by a set of parentheses. I like to think of the parentheses as a pair of telephones talking to each other. That's one trick I used to remember that's how to call a function. So follow the function name with the set of parentheses, and when I invoke this function once, we will execute any code within this function once. If I need to repeat this code 3 times, I will just have to call this function 3 times. We are calling our birthday function 3 times. And there we go, we have invoked this birthday function 3 times, and we have accomplished our goal of singing 3 verses of Happy Birthday. So basically, that's all what a function is. It's some subsection of code that is executed whenever you invoke it, also known as calling a function. A benefit to using functions is that if you think you're going to use some code more than once, you can stick it within a function, and then to repeat that code, you just call the function as many times as you need. So yeah, those are functions. If you would like a copy of this code, I will post this to the comments section down below, and in the next video, we will discuss arguments and parameters. So yeah, that's the basics of functions in C. Hey, what's going on, people? So let's talk about arguments and parameters. I have a function named birthday, which we discussed in the previous video. This will print 2 lines of text. Happy birthday, dear X. You are Y years old. What I would like to do is replace X with a user's name and Y with a user's age. So here's how we can write a program like that. So let's begin by, within the main function, declaring 2 variables, a character array named name, and assign this your first name, and an age. And this will be of the int data type, and let's say that this will be age, and make up some age. I like to think that I'm still 21 years old. Okay, so if I try and display name and age, you think this would work, right? So I'm going to use a format specifier, then s, to display a string, and then I will display our name variable, and with y, let's display our age. So let's use d for our format specifier to display an integer, and we will display age. Now here's the problem. You can see that we have some red underlines. Name is undeclared as well as age. Here's the deal. Functions can't see inside of other functions. Our birthday function is unaware of our name and age variables. One way in which we can make our birthday function aware of these is to pass them as arguments when we invoke the birthday function. So based on the last topic on functions, I mentioned that when we call a function, we type the function's name followed by a set of parentheses. I like to imagine the set of parentheses as a pair of telephones, and these two functions are talking to each other. Our main function needs to make our birthday function aware of our name and age variables. So what we can do is pass these variables as arguments. So between the parentheses, we can add our variables separated with a comma. So let's pass name and age. So anything that you're passing to a function are known as arguments, but we need a matching set of parameters within the function declaration. So between this set of parentheses, we will list our name and age variables, but precede each with the data type that we're working with. So we have name and age. So age is an integer, so precede the variable name with int. And name is a character array, so we're going to precede name with char, and then add a set of straight brackets after. So these are parameters. Parameters are what this function needs in order to be executed. So this does work. Happy birthday, dear bro, you are 21 years old. So with parameter setup, you can only call this function if you pass a character array as well as an integer. If I were to remove these arguments, we can no longer call this birthday function. Error, too few arguments to function birthday. So when you call a function, you can pass some arguments, but you need a matching set of parameters. And the names of these parameters don't necessarily have to be the same. What's important is the order of the arguments and the data type. So let's say name is X and age is Y. So let's replace that here as well. And that would work too. So yeah, those are arguments and parameters. Arguments are what you're sending a function. Parameters are what a function expects when it's invoked. And the benefits of arguments and parameters is that these functions can talk to each other because functions can't see inside of one another. So if you have some variables within a function, you can pass them to another function as arguments. So yeah, those are arguments and parameters. If you would like a copy of this code, I will post this in the comment section down below. And well, yeah, those are arguments and parameters in C. Hey, what's going on, people? So the return statement returns a value back to a calling function. Here's an example. I have a function named square. Square is going to accept one argument, a double. It's going to square that double and return the result back to the calling function. So here's an example. Let's say we have double x, and I'm going to call the square function and then pass in some value. Let's say 3.14. So when we call a function, we can also return a value back to the spot in which we called the function. So within our square function, let's set double result equal to x times x, effectively squaring it. So to return a value back to the calling function, we will use this return keyword, followed by some value or variable. I would like to return result. However, we need to list the data type of what we're returning within the function declaration. Right now it's void, so if we're returning a double, we will list double here. If this was an integer, we would return int. If it was a character, we would return char. You kind of get the idea. So result is a double, so we need to change this from void to double, and we will return this result back to the calling function. So we're effectively stating that double x equals 3.14 squared, and then let's print the result. So printf, the format specifier for a double is lf, and we will print x. And 3.14 squared is 9.859. Now you could shorten this too. We could just say return x times x. Instead of declaring a local variable, return x times x. And that would work the same. So yeah, that's basically the return statement. You can place it within a function and return a value or variable back to the calling function in the spot in which you invoked that function. But if you're going to return a value or variable within the function declaration, you need to change void to the data type of what you're returning. So yeah, that is the return statement. And you may have noticed within our main function, we're returning 0. 0 is the exit status if this program runs successfully. So instead of void with our main function declaration, we have int because 0 is technically an integer. So yeah, that's the return statement. If you would like a copy of this code, I will post this to the comment section down below. And well, yeah, that's the return statement in C. That's the return statement in C. Hey, sup people? The ternary operator, also known as the conditional operator, it's a shortcut to using an if-else statement when assigning or returning a value. Here's the formula. We write a condition followed by a question mark. If this condition is true, we return some value if true. Or, if that condition is false, we return some other value. Here's an example. First, we'll use an if-else statement. We'll post this to the comment section down below, and well, yeah, that's the return statement in C. Hey, sup people? The ternary operator, also known as the conditional operator, it's a shortcut to using an if-else statement when assigning or returning a value. Here's the formula. We write a condition followed by a question mark. If this condition is true, we return some value if true. Or, if that condition is false, we return some other value. Here's an example. First, we'll use an if-else statement, and then later we'll switch to the ternary operator. So let's create a function that will find the maximum of 2 integers, and I'm going to assign that to int max. And we will invoke a function find max, but we'll still need to declare it. So let's pass in 2 integers, maybe 3 and 4, and then I'm going to display whatever max is. Okay, so let's declare this function. So we're returning an integer. The name is find max, and let's set up some parameters, int x and int y. So if we're using an if-else statement, if we need to return x, if it's larger, we can check to see if x is larger than y. If so, then return x. Else, return y. So this does work. So the max between 3 and 4 is 4. So if I switch 3 to 5, well then the max is 5. So a shortcut to writing an if-else statement like this, if we're returning or assigning a value, is that we could instead use the ternary operator. So let's return, and then we have a condition. So this is our condition. Is x greater than y? Then we add a question mark. Then the value we're returning if true. So if x is greater than y, let's return x, colon, then our value if this condition is false. And here, within our else statement, we're returning y. And we no longer need this if-else statement, and that's all there is to it. So we cut down on all that code and now just have one line of code. So it's kind of like a shortcut, and this works much the same. So the maximum between 5 and 4 is 5. And if I change 5 back to 3, well then the max is 4. So yeah, that's the ternary operator. It's a shortcut to using an if-else statement when assigning or returning a value. You write some condition, add a question mark like you're asking a question, then list some value to return if this condition is true, and then some other value if this condition is false. So you just follow this formula. So yeah, that's the ternary operator. If you would like a copy of this code, I'll post this to the comment section down below. And well, yeah, that's the ternary operator in C. Hey everybody, so let's discuss function prototypes. A function prototype is a function declaration without a body before we declare the main function. It ensures that calls to a function are made with the correct number and type of arguments. It has some benefits which we'll discuss later. Basically, this is another way in which we can declare and define functions. In the last few topics, when we were declaring functions, we were doing so before the main function. So let's say void, and we have a function named hello. And there will be two arguments, an array of characters named name and int age. And what I would like this function to do is print a message using our name and age. So hello name. You are age years old. So what we're going to do is now move this function from before the main function to after the main function. And let's declare some name and age variables. So char name, use your first name, and int age, make up some age. Now I'm going to invoke my hello function, but pass in an incorrect number of arguments. Now here's one of the benefits of a function prototype. It's going to ensure that we have the correct number of arguments when we invoke a function. So the correct arguments for our hello function are an array of characters and an integer. What if I'm missing one of these arguments? Let's say we only pass in a name, and then invoke this function. So this is going to result in unexpected behavior. And we do have a warning here, conflicting types for hello, but this program will still compile and execute. So here's the result. Hello bro, you are 1,512,352 years old. And if I run this again, this will probably be a different number. So this will result in unexpected behavior. We're not ensuring that calls to a function are made with the correct arguments. One way in which we can do that is to add a function prototype before the main function. And to add a function prototype to a given function, we will declare that function but not give it a body before the main function, and then we will later add a body and define what this function is going to do. So before the main function, we will type the return type of this function, void, the name of the function, hello, and then add the data type and the order of arguments. So we have a character array and an integer, then end it with a semicolon. So this is a function prototype. It ensures that calls to a function are made with the correct arguments. So now if I attempt to call the hello function with only one argument when two are required, instead of a warning, we'll receive an error. And it states that there are too few arguments to function hello. So this program will not compile and run successfully, which is what we want, because we made a mistake. And if I were to add the correct arguments now, well then this program is going to compile and run fine. So here's some important notes regarding function prototypes. Many C compilers do not check for parameter matching. That's why this program was still able to compile and run without a function prototype, even though we were missing arguments. And that can result in unexpected and unwanted behavior, such as saying that I was over 1,000,000 years old. So a function prototype causes the compiler to flag an error if arguments are missing. You can write the functions before the main function. That's okay too. But a few advantages of using a function prototype is that it's easier to navigate a program when the main function is at the top of your file. It also helps with debugging, and it's commonly used in header files, which is something we need to discuss in a future topic. So yeah, that's basically a function prototype. We're going to define any functions after the main function now, and before the main function, we will declare a function prototype. One function prototype for each function we have besides the main function, and this ensures that we have the correct number and type of arguments, which will prevent any unexpected behavior. It's basically just another way to declare functions that you may run into in the future. So yeah, those are function prototypes. If you would like a copy of this code, I will post this to the comment section down below. And well, yeah, those are function prototypes in C. Hey everybody, so now that we know how functions work, I thought this would be a good opportunity for us to learn about some useful string functions. So there's a lot of string functions that are already written for us. Just include this header file at the top, include string.h. So create two strings, one named string1 and the other named string2. String1 will be your first name, string2 will be your last name. And then at the end of this program, I am just printing string1 using a printf statement. So let's begin. The first useful string function is string lower. So whatever string you pass in as an argument, this function will convert a string to lowercase. So the first letter in my name is uppercase, it's capitalized. So after passing in string1 into this function, my name is all now lowercase. Otherwise, there's string upper that will convert a string to uppercase, and my name is uppercase. String cat will concatenate, as in append string2 to the end of string1. So we will append the second argument to the first argument. So if I pass in string1, then string2, this will append my last name to my first name, and these strings are now combined. Or I could append a given amount of characters from string2 to string1. So the third argument is a number. If I append one character from string2 to string1, then this will take the C from my last name and append it to the end of my first name. So that is the string and cat function. There's also string copy, and this one is actually fairly common. So this will copy string2 to string1. If I print string1, well, it now displays code instead of bro. This will remove the contents from string1 and replace them with string2. Or you could copy a given amount of characters from string2 to string1. Let's say that I'm going to copy the first character over. So I'm copying the first character from my last name to my first name. And my first name is now Crow. Or I could set this to 2. And this will copy the first two letters over. Coo. Alright, here's a few more. So string set will set all characters of a string to a given character. I'm going to set all of the characters from string1 to a question mark. All of the characters within my name are all question marks. And string n set will set the first n characters of a string to a given character. So I'm going to set the first character of my first name to an x. So my name is now xbro. And string reverse will reverse a string. So if I reverse string1, my first name is now orb. So this next set of functions will return an integer. So I'm going to declare a variable int result. And this function is really common, string length. This returns the string length as an integer. If I pass in string1, this string has a length of 3 characters. And then I'm going to print my result. And this is an integer. So the length of my first name is 3 characters. This is a fairly common function. The string compare function will compare all of the characters within 2 strings. If they're the same, they will return 0. If they're different, they will return a number besides 0. So here's an if statement. If result is equal to 0, we will print these strings are the same, else these strings are not the same. So my first name is not equal to my last name. These characters are different. So this code will print these strings are not the same. And let me get rid of that printf statement. Okay, now if I make these strings the same, then result is going to be 0. These strings are the same. and you can compare a given amount of characters too. So currently, I have these strings set to be the same characters. So this will compare only the first character. These strings are the same. Even if I change the other characters, the first characters will still be the same. So this function will return 0. There are two additional versions of string compare and string nCompare. They are string compare I and string ni compare. So these will do the exact same things, except they ignore case sensitivity. So yeah, everybody, those are just a few useful string functions. There's still a lot more located within this header file, but we would need to understand how things like pointers work, which we have not discussed yet, but I thought I would at least cover some of the basics. So yeah, those are a few useful string functions in C. If you would like a copy of all these notes, I'll post them to the comment section down below. And well, yeah, those are a few useful string functions in C. Hey, welcome back. So we have to talk about for loops. A for loop repeats a section of code a limited amount of times. Here's an example. Let's say that we would like to count the numbers 1 through 10. So we can actually write a for loop to do that for us. And here's how to create one. Type for, a set of parentheses, then a set of curly braces. Anything within this set of curly braces we can repeat a limited amount of times. But before we do so, there's a few statements we have to add to our for loop. There are three. The first is that we need some sort of counter or index. And we can actually declare that within the for loop. So we will declare an index, int index, and set this equal to some number, let's say 1. So we will start at 1 and count to 10. And then finish the statement with a semicolon. Now, a common convention is that a lot of people will shorten index to I because it's easier to work with. So this is the first statement, there's two more. And the second statement is a condition. How long should we continue repeating this code? So let's continue this for loop as long as I, our index, is less than or equal to 10. And then add a semicolon at the end. So that is the second statement. And the third statement is that we can increment or decrement our counter. So let's take I and increment it by 1 after each iteration by using I++. So let's just test this. So printf, I'll just print the word test. So this should print the word test 10 times. Then we should add a new line character at the end. That's much better. Okay, now let's replace test with a format specifier. We're displaying an integer. And let's display I, our index. And this should count from 1 to 10. Yep, just like that, 1 through 10. So with this third statement, we can increment or decrement by 1 or a greater number. So this time, let's count by 2. So we can set this to I plus equals 2. And we will now count up by 2, starting from 1. 1, 3, 5, 7, 9. Or how about 3? 1, 4, 7, 10. You can also decrement. This time, let's count it from 10 to 1. So let's set I to equal 10, and we will continue this as long as I is greater than or equal to 1, and we will decrement I minus minus. So this will count from 10 to 1 and then stop. Or we could count down by 2. I minus equals 2. Then we have 10, 8, 6, 4, 2. Or even 3 or a greater number. So yeah, that's a for loop. It repeats a section of code a limited amount of times. There's up to 3 statements that we can add. We can declare an index, a counter, so to say, some condition that we check after each iteration, and then some way to increment or decrement our index. And then place any code you would like to repeat within a set of curly braces. So yeah, that's a for loop. If you would like a copy of this code, I will post this to the comment section down below. And well, yeah, those are for loops in C. Alright, we're back at it again. So let's talk about while loops. A while loop will repeat a section of code possibly unlimited times. We will continue some section of code while some condition remains true. And it's possible that a while loop might not execute at all depending on what our condition is. So here's an example. Let's create a program that will ask a user for their name. If they attempt to skip that prompt, then we will keep on asking them for their name indefinitely. So here's how we can write a program like that using a while loop. We'll need to begin with a character array, let's say name, and this will be 25 bytes. And we will create a prompt using printf. What's your name? We can use scanf for user input, but with names that may contain spaces, I'm going to use fgets instead. Refer to the video on user input to learn more about fgets. So I would like to assign my variable name, set the size of the user input 25 to match what we have, then type stdin for standard input. Then we just need to get rid of the new line character at the end of our user input. So we can write something like this. Set our character array of name, and within the straight brackets, we will use the string length function, pass in name, -1. And we will set this equal to a null character. And then at the end, we will display the user's name. Printf, let's say hello, and then use a format specifier for strings, which is s. And we will display a user's name. Okay, this is what this looks like currently. What's your name? I'll type my name, hit enter, and it says, hello, bro. Now, what if I don't type in anything? Like I just hit enter. What's your name? I'm going to hit enter, hello, and then there is no name here. How can I force a user to type in something? Well, I could use a while loop, and that will prompt a user to enter their name indefinitely. So here's how to create a while loop. Type while, parentheses, curly braces, and we need a condition. What are we going to check? We will continue this while loop while some condition remains true. Our condition to check to see if we have an empty string, we could use the string length function, pass in name, and check to see if this is equal to 0. If it is 0, that means that somebody just hit enter without typing in anything. So let's print a message to yell at them. You did not enter your name. And then let's copy this section of code and paste it to reprompt the user to type in their name. And that's all there is to it. So while this condition remains true, we will execute this code forever. So let's try it again. Okay, what's your name? I'm going to hit enter. You did not enter your name. What's your name? No, 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 no. Okay, I give up. Hello, whatever your name is. So yeah, that's basically a while loop. It repeats a section of code possibly unlimited times. There's a lot of overlap where you could use either a for loop or a while loop, and we execute some body of code while some condition remains true. However, a while loop might not execute at all if this condition is false to begin with. So if the user actually does type in something, well, this condition is false, and we do not execute this body of code. So yeah, that's a while loop. It repeats a section of code, possibly unlimited times. If you would like a copy of this code, I will post this to the comment section down below. And well, yeah, those are while loops in C. Hey everybody, so let's talk about do while loops. A do while loop is a variation of a while loop. So a while loop first checks a condition, then it executes a block of code if that condition is true. So we may not even execute that block of code at all if that condition is false from the get-go. A do while loop always executes a block of code once, and then we check a condition at the end. If that condition is true, we will continue another loop. So here's what I'm thinking for a demonstration. We'll create a small program where we will have a user type in as many numbers as they want, as long as it's above 0, and then we will find a sum. So if we're writing a program like that, we can first declare two variables, int number. I'll go ahead and assign these some values right away. So we'll set number to 0 and int sum equal to 0 as well to keep track of the sum. We'll first begin by creating a while loop. So we will use a while loop, and our condition is if number is greater than 0, then we will continue to ask the user to type in some numbers. If that number is 0 or less, then we stop. So let's ask a user for a number. Enter a number above 0, and then using scanf, we will accept some user input and store this within number. And let's check to see if number is greater than 0. If it is, we will take sum, set this equal to sum, plus number. But you can just shorten the statement to plus equals number. That's fine too. And then at the end, we will print whatever the sum is. Sum, we're displaying an integer, and we are displaying sum. So with our number, I set this to 0, and since our while loop is checking the condition first, we're not actually going to execute this body of code. So our program skipped this while loop and went straight to the printf statement. So a while loop checks a condition first. A do while loop will check a condition last. So to change this to a do while loop, we will take our condition and move it to the end, just after the last curly brace, and add a semicolon. And then before the first curly brace, we will add the word do. So we will do this once, and then check the condition to see if we would like to continue. So now if I run this, we get that prompt, enter a number above 0, and I can type in as many numbers as I want. So 1, 2, 3, 4, 5. So we check the condition at the end. So our condition is that if our number is greater than 0, we will continue this loop. So if I type in -1, we will exit. And our sum is 15. So that's the major difference between a while loop and a do while loop. A while loop checks a condition first, then executes a block of code if that condition is true. A do while loop always executes a block of code once, then checks a condition. If that condition is true, then we continue again. So yeah, that's a do while loop. It's a variation of a while loop. And if you would like a copy of this code, I'll post this to the comments section down below. And well, that's the do while loop in C. Hey, welcome back. So, nested loops. A nested loop is a loop inside of another loop. When you'll encounter them, it's really situational, so I don't really have one good example. But what I'm thinking we'll do is use a nested loop for an exercise. What I'm thinking is that we'll let a user type in a number of rows and columns and a symbol and print a rectangle of that given symbol, but the user is going to specify a number of rows and columns. So let's begin by declaring all of the different variables that we'll need: int rows, int columns, and char symbol. We'll let the user type in a number of rows and columns. Enter number of rows. Then use scanf to accept some user input. We are accepting an integer, so use D for the format specifier. Address of operator, rows. Then do the same thing with columns. Enter number of columns. Let's create our nested loops. You can use either for loops or while loops. It's just the concept of one loop inside of another. So let's use for loops for our outer loop and inner loop. The outer loop is in charge of keeping track of the rows. The inner loop will be in charge of keeping track of the columns. So I need this outer for loop to iterate once for every row that we have. So we could write something like this. Int I, set this equal to 1. I need to continue this for loop as long as I is less than or equal to rows. And then increment I by 1 after each iteration. So now let's create a nested for loop. We will declare a loop inside of another loop. And this inner for loop is in charge of the columns. We should probably not reuse our index of I, so let's create a new index. And a common naming convention for an inner for loop is to use J, because J comes after I in the alphabet. So I will set int J equal to 1. We will continue this as long as J is less than or equal to columns, then increment J by 1. For the time being, until we let a user type in a symbol, let's just print our index. So let's use printf. We're displaying an integer, and let's display J. And let's take a look at this. Okay, enter number of rows. How about 3 rows and 5 columns? So here's our output. We have the numbers 1 through 5 3 times. So to make this more of a rectangle, a grid, I'm going to add a new line character whenever we finish a row. So printf, new line character. Let's try that again. Enter number of rows, 3, number of columns, 5. So we have 3 rows and 5 columns. Basically speaking, to complete one iteration of our outer loop, we have to escape our inner loop first. Once this condition is no longer true, then we will escape the inner loop and complete one iteration of the outer for loop. But then once we begin the next iteration of our for loop, we're stuck back within our inner for loop again. So that's kind of the concept. Now this time, let's let a user type in a symbol, and we will create a sort of rectangle. Enter a symbol to use. Then scan F, we are accepting a character, so use the C format specifier, address of operator, our symbol variable. Now we're going to replace J with our symbol, and the format specifier for a character is C. Then let's try this again. So how about 3 rows and 6 columns? Okay, here's the issue. So we have all of this empty space. Now when we entered our number of columns, after hitting enter, we have the new line character within our input buffer. So our next scanf function actually picked that up. So what we need to do is clear our buffer, and one simple way of doing that, there's a couple different ways, is that we can just use scanf again, and we will read a character. And that's one way to do it. Basically with this line, we're just getting rid of the new line character after the last time we used scanf, because that's still within our buffer. Okay, let's try this one last time. What about 4 rows and 5 columns? Enter a symbol to use. How about the $sign? There we go, here's our rectangle. It has 5 columns and 4 rows. So yeah, that's basically a nested loop. It's a loop inside of another loop. And when you'll encounter them, it's really situational. I thought this would be good practice to understand how they work. To complete one iteration of the outer loop, you have to first escape the inner loop, and that may involve completing all iterations of the inner loop. So yeah, those are nested loops. If you would like a copy of this code, I will post this to the comment section down below, and well, yeah, those are nested loops in C. Hey people, I have a super quick video for you today on the differences between the continue and break statements. So when using either statements within the context of a loop, a continue statement will skip the rest of a section of code and force the next iteration of a loop. A break statement will exit out of a loop entirely. Another place where you see break statements is when used within a switch after each case. So here's an example. Let's say that we would like to count the numbers 1 through 20, but I would like to skip the number 13 because 13 is considered an unlucky number. So if I were to write a program like that, that would look something like this. So let's use a for loop, and I will set an index of I equal to 1, continue this as long as I is less than or equal to 20, and then increment I by 1. Then let's print our index. So printf, we're displaying an integer, and let's display I. I'm just going to add a new line character after each iteration when we use a printf statement. Okay, so this is what this looks like. We have the numbers 1 through 20. So if I would like to skip the number 13, I can use a continue statement. But we need to check to see if I is equal to 13. We can use an if statement. So if I is equal to 13, then we will continue. And let's take a look. So we have the numbers 1 through 20, but we are missing 13. So a continue statement will skip the rest of a section of code and force the next iteration of a loop. Now, if this was a break statement, this will break out of our loop entirely. So once we reach 13, then we will exit out of this loop entirely. So here we only have the numbers 1 through 12, and then we break, we exit out of the loop. So that's a quick demonstration of the differences between continue and break. The continue statement will skip the rest of a section of code and force the next iteration of a loop. A break statement exits out of a loop entirely. So yeah, that's a super quick video on the differences between the continue and break statements. If you would like a copy of this code, I'll post this to the comment section down below. And well, yeah, those are the major differences between the continue and break statements in C. Hey everybody, let's talk about arrays. An array is a data structure that can store many values of the same data type. Here's an example. Let's say I have a variable named price, and I have the price of maybe one item in a fictional store of ours. So by using an array, we can actually store more than one value, but it has to be of the same data type. So I can turn this variable price into an array, and I can do that by following the name of the variable and add a set of straight brackets. And then any values I would like to add to this array, I will surround with a set of curly braces. And there we go, we have turned our variable price into an array. But I'm going to change the name to prices because I think it would be more descriptive, because we can store more than one value now. So we can add multiple values, each separated with a comma. So let's say we have another price that is $10, $15, $25, and maybe 20. Now you may have noticed some parallels when we create a string. It's really an array of characters. So if I need a name, we would say the data type is char, and we will create a name array followed by a set of square brackets, and I will set this equal to some amount of characters. A string is really just an array of individual characters, and with my name here, I have 3 individual elements, 3 individual values. Now, if I need to access one of these values, I need to use an index number. So let's print one of these numbers. So printf, I'm going to use the format specifier for a double, and I'm going to list my array name, prices, then follow this with a set of straight brackets. Then I need an index number. So each spot within an array is known as an element. So we have 5 elements within our array. And to access one of these elements, I need to list an index number. The first element has an index number of 0 because computers always start with 0. So if I display prices at index 0, this contains the number 5. I'm actually going to format this. Let's display 2 digits after the decimal, and I'll precede this number with a $sign. Much better. Alright, so then if I display prices at index 1, that is technically our second number of $10. So prices at index 2 is 15. 3 is 25. And 4, which is our last element, is 20. So arrays, they have a fixed size. We can't change the size after we compile and run our program. Another thing that you can do too, if you do not know what values you would like to initialize your array with, you can always just set a size. Let's say I would like a size of 5 elements, but then I'll assign some values later. So later on in our program, we can say prices at whatever index, let's say index 0, I'm going to assign with 5. And I'll do the same thing for the other elements. So prices at index 1 is maybe 10. Prices at index 2 is 15. 3 will be 25. And 4 will be 20. That's another way in which you can initialize an array. You can always set a size and then add elements later. Another option is that you could combine the two. We could set a size right away. So maybe prices will have a size of 10, and we can right off the bat assign some values right away. So we have 5 elements that are currently filled, but then the other 5 are empty. So there's a few different ways in which you can initialize an array. So yeah, that's basically an array. It's a data structure that can store many values of the same data type. Initializing an array is much like creating a variable, except you will add a set of straight brackets after, and then you can either add some values right away or later on in your program, but you need to list an index number of where you're placing a value within the array. And then to access a value within your array, you type the array name followed by an index number, kind of like a parking spot number. So yeah, those are arrays. In the next video, I'm going to show you how we can iterate over the elements in an array using a for loop. If you would like a copy of this code, I will post this to the comment section down below. And well, yeah, that's an introduction to arrays in C. Hey, welcome back everybody. In this video I'm going to show you how we can loop through and print the elements of an array. So I have an array of doubles named prices, and I just made up some fictional prices. To display one of these elements, I can use a printf statement. I will use the appropriate format specifier for the elements displayed within this array. Since this array contains doubles, I will use the format specifier for a double. Then to access one of these elements, I will type the name of my array, followed by a set of straight brackets, then an index number. So the first element in an array is 0 because computers always start with 0. Then if I need to display the other elements, well, I would have to manually type prices at index 0, then 1, 2, 3, 4, so on and so forth. So this does work if you have a couple elements, but what if you have hundreds? This method is not going to be practical. A better solution is that we could make a for loop, and this for loop will iterate once and display each element of this array. So let's create a for loop. For, parentheses, curly braces, and we'll need an index. Int I, I'll set this equal to 0. Then we'll need a condition. For the time being, let's set I less than 5. But later on, we're going to replace 5 with something else, and I'll explain that later. And then we will increment I by 1. So then, during each iteration, let's use this print statement again, and make one change. Instead of setting an index number, let's use our index instead. Then I'm just going to add a new line character after each printf statement. So here we go. This for loop should iterate 5 times. And it will display the elements within our array. So we have 5, 10, 15, 25, 20. Maybe I'll add a couple extra things to this format specifier. Let's display 2 digits and a $sign. That's much better. So this kind of resembles maybe a receipt of some sort, like somebody just bought a bunch of items. Okay, now here's one situation. What if we add or remove elements from this array? Let's say that a user purchases one more item for $30. Now, the way that this for loop is written, it's not going to display this last element because we set this for loop to iterate as long as I is less than or equal to 5. It's not going to display this last element, so we would need some way to update this condition. A better solution, instead of using a number here, is that we could calculate the amount of elements within our array and loop that many times. And one way in which we could do that is to use the size of operator. So let me demonstrate the size of operator real quick. It will return the size of an operand in bytes. So let's print this. So this will be an integer, and we will use the size of operator and pass in our array of prices. So this size is going to be in bytes. So the size of our array in bytes is 48 bytes. We have 6 elements made up of doubles. Each double uses up 8 bytes, so 6 times 8 is 48. So now let's use the size of operator instead. Size of prices, but we are going to divide the size of our array by the size of one of these elements. They're all going to be consistent because they all have the same data type. So we will take size of prices divided by the size of one of these elements. Let's say prices at index 0. So 48 divided by 8 equals 6. We will iterate through this for loop 6 times. And here's our array. We have 5, 10, 15, 25, 20, 30, and we can add or remove elements freely, and there's no need to update our code, because we may not remember to do that later on. So yeah, that's one way to loop through and print the elements of an array. You can use a for loop, then use a printf statement, and for the index of your array, you can use the index of your for loop. Then if you would like your for loop to calculate how many times it's going to iterate through this array, you can use the size of operator, pass in prices, divided by the size of one of the elements. And that will calculate how many elements are within your array. So yeah, that's one way to loop through the elements of an array. If you would like a copy of this code, I'll post this to the comment section down below. And well, yeah, that's how to loop through and print the elements of an array in C. Hey everyone, two-dimensional arrays. It's an array where each element is an entire array. It's useful if you need a matrix, grid, or table of data. Let's begin by creating a simple one-dimensional array of maybe some numbers. So the data type is int, the array name will be numbers, and let's initialize this array with a few numbers, 1, 2, and 3, something simple. So if I would like to store a grid or matrix of data, these elements will be the first row, and I can add a second row. So separate each row with a comma, then another set of curly braces, and then you can add more values. So let's say 4, 5, and 6, and we'll stop here. With these separate arrays, we will surround with a set of curly braces, and preceding the first set of straight brackets, we will add a second set of straight brackets. So this is now a two-dimensional array. However, with a two-dimensional array, we have to specify a maximum size of elements within each of these arrays. Let's say that each of these arrays will have a maximum size of 3 elements apiece. So within the second set of straight brackets, I will list 3. And you can, although it's not necessary, set a maximum amount of arrays within your two-dimensional array. So let's say 2, because we have 2 separate arrays within our two-dimensional array. Now, to better visualize how this is more or less a table of data, I'm going to rearrange these. So this may be a better visualization. This first set of straight brackets is for the number of rows, and the second set of straight brackets is for the number of columns. So we have 2 rows and 3 columns within our two-dimensional array. Now you can declare a two-dimensional array but not assign values quite yet, but you'll need to set a maximum size. So right now I'm just going to turn this into one giant comment, and let's declare a two-dimensional array with 2 rows and 3 columns. And here's how to assign some values. We will type the name of the array, followed by 2 sets of straight brackets. We need a row number and a column number. So the first column within the first row is going to be 0, 0, because computers always start with 0. And let's assign this a value of 1. The second column within the first row would be 0, 1. And let's assign 2 there. Then 0, 2. And that will be number 3. So the first column within the second row would be numbers 1, 0, and this will be 4. Then we will follow the same pattern. So where 5 was, that would be 1, 1. And 6 is 1, 2. So this is another way to initialize an array. You can set a maximum size and then assign some values later, or you could assign all of the values right from the beginning if you know what they are. Okay, now how can we display the elements of a two-dimensional array? We'll have to use nested loops. So let's create a for loop, and I will declare an index of I, set this equal to 0, and for the time being, I'm going to say I is less than the number of rows that we have. So right now we have 2 rows, but we're going to change this value later to something that's more flexible that will calculate the amount of rows that we have, and then I will increment I by 1. Now let's create a nested loop that's in charge of keeping track of the columns. And let's use an index of j because we do not want to reuse I. So set j equal to 0. We will continue this as long as j is less than however many columns we have, 3, a maximum of 3. And then increment j by 1. So during each iteration of the inner for loop, let's display one of these elements. So we will use the format specifier for an integer, d is fine, followed by our array, numbers, and then we have 2 indices. So the row is going to be I, and this will begin at 0, and the columns is j. This will also begin at 0. So after each iteration of the inner for loop, we will increase j. When we finish the inner for loop, we will increment I by 1. So by using nested for loops, we can iterate over all of the elements of this array. So I'm just going to add a space after our number, and we should probably add a new line after each row. So I'll add a new line. Let's test this. Here we go. We have our table of 2 rows and 3 columns. Now there's one situation that we may run into. What if we change the amount of rows and columns that we have? So let's say that we add 1 more row. Our 2D array of numbers will have 3 rows and 3 columns. Row 2, column 0 equals 7. Row 2, column 1 will equal 8. And row 2, column 2 will equal 9. So if I were to run this again, well, this last row is not going to be displayed. So it would be better if we can calculate how many rows and columns are within our two-dimensional array. And here's one way to do so. I'm going to declare 2 new variables, int rows and int columns. And I will set the condition of the outer for loop to be as long as I is less than rows. And the inner for loop will be j is less than columns. Now we just need to calculate what these numbers are going to be. To calculate rows, we can use the size of operator, and then pass in the entire size of our two-dimensional array. And we're going to divide this by the size of one of our rows. They're all going to have the same size. So we can pass in our array numbers and then specify one of the rows. Let's say the first row. They're all going to be the same. Okay, so that's how we can calculate the number of rows that we have. Now to find the number of columns, we can copy what we have here and then just make a few changes. So we will say the size of the first row, row 0, divided by the size of one of the elements found within the first row. So we can say 0, 0. And let's print the amount of rows and columns that we have just to test it. So we have rows and columns. I'm just going to add a new line character real quick. Okay, so we have 3 rows, 3 columns. And here's our table. 3 rows with 3 columns apiece. So yeah, that's basically a two-dimensional array. It's an array of arrays, where each element is an entire array. It's useful if you need a matrix, grid, or table of data. And in this example, we made a table of integers, just the numbers 1 through 9. So there's a couple different ways in which you can initialize a two-dimensional array, but you'll need 2 sets of straight brackets. It's optional to set a maximum number of rows, but it is necessary to set a maximum number of elements within each row. And then to access one of the elements, you use 2 indices. One for the row, one for the column. So yeah, those are two-dimensional arrays. If you would like a copy of this code, I'll post this to the comment section down below. And well, yeah, those are two-dimensional arrays in C. Hey everyone, in this video I'm going to show you how we can create an array of strings. Let's say we will have an array named cars. So we will need a two-dimensional array, so we need 2 sets of straight brackets, and within the second set of straight brackets we will specify a maximum size for each of these elements. Let's say maybe 10 characters. So a string is already an array of characters. Let's add our first string. Maybe we have a Mustang. So to add a second element, we would separate the next one with a comma, then we can add another string. Let's say we have a Corvette, and then one more. How about a maybe Camaro? Okay, so with all of these different strings, I'm going to surround with a set of curly braces. And here we go, we have an array of strings. It's basically a 2D array of individual characters, except each element is a string. Now, one important difference with an array of strings is that we can't directly change one of the values. Let's say cars at index 0 equals a Tesla. And then I'm going to try and run this. So we can't directly assign a new value. One way in which we can do so is to use the string copy function. So if you're going to use the string copy function, include this import, string.h. Okay, so to update one of the values, I will use string copy, pass in my array, and an index number, followed by a string. So let's say a Tesla, and this would work. Now to display an array of strings, we can use a for loop. And there's no need for a nested loop, so we will create an index I, set this equal to 0. I would like to continue this as long as I is less than, and we will calculate how many elements are within our array. So we will use the size of operator, pass in our array, divided by one of the elements, size of cars, and maybe the first element of 0. And then increment I by 1 during each iteration. So then during each iteration, let's display one of these elements using a printf statement. Let's display a string. I'll add a new line after each printf statement. And let's display our array cars at index of I. So this should display Tesla, Corvette, and Camaro in that order. Tesla, Corvette, and a Camaro. So yeah, that's an array of strings. It's really a two-dimensional array of characters, but it involves less steps, because each of these strings is already an array. And if you need to update or edit one of the values, you can use the string copy function. So yeah, that's how to work with an array of strings. If you would like a copy of this code, I'll post this to the comment section down below. And well, yeah, that's how to work with an array of strings in C. Alright, what's going on people? So in this video I'm going to show you how we can swap the values of 2 variables. Now you may be wondering, why the heck do we need to know this? So swapping variables is actually very common within sorting algorithms. And when we reach the next topic on sorting arrays, we'll need to learn how to do this. So let's begin. I have two variables, x and y. X contains the letter x, y contains the letter y. And let's print these values. I'll use a printf statement. Let's display x and y. X equals x, y equals y. So how can we swap these? Let's try x equals y and see what happens. Within both x and y, the value is y. What about y equals x? Well then, both variables contain the character x. So what can we do? It seems like we're stuck. What we could do is that we could introduce a third variable. Let's say char, and let's name this temp because it's a temporary variable. So we have a third variable to work with as temporary storage for some value. So let's assign temp is equal to x, and then we will assign x equals y, and then lastly, y equals temp. And this should work. Let's try it. Yep, x equals y, and y equals x. Now this is a little bit different if you're working with strings. So let's say these are character arrays. And we'll pretend that these are maybe glasses holding some fluid. X contains water, and y contains maybe lemonade. And let's make temp a character array as well, but we need to declare a size. Let's say 15. Okay, so this isn't going to work. We're already receiving problems. Expression must be a modifiable L value. So when working with arrays, it's not enough to simply assign values. We could use the string copy function. So let's get rid of these, and we will use string copy. Oh, also make sure that you include this header file. Okay, so we will copy the contents of x over to temp. And it's the same procedure as before. String copy y over to x, and string copy temp over to y. And then make sure you change these format specifiers to strings. X did contain water, now it contains lemonade. Y did contain lemonade, and now it contains water. When swapping variables, I like to imagine my variables as glasses, and they contain some fluid. If we pour the contents of one glass into the other, well then the contents will be pushed out and overflow. So it would be wise of us to introduce a third glass that's empty to hold one of these fluids, so then we can pour the contents of one variable into the other. Now here's one issue that you may run into when using the string copy function. If the length of the second argument is less than the first argument, this can lead to unexpected behavior. I'm going to replace lemonade with soda, and let's see what happens. So x doesn't contain anything, but y contains water. One solution is that we can make these character arrays the same size. Let's say that they're both 15. And that should solve that issue. So that's something you may need to take into consideration when using the string copy function if you're going to swap strings. So yeah, everybody, that's how to swap the values of two variables. If you would like a copy of this code, I'll post this to the comment section down below, and in the next video I'm going to show you how we can sort the elements within an array. And well, yeah, that's how to swap the values of two variables in C. Hey, what's going on, people? So in this video, we're going to write a small program to sort the elements of an array. Let's begin with an array of integers, and then later we'll create an array of characters. The data type will be int, and let's name this array. And assign some values. Make sure that they're not in order. Just make up some numbers, that's fine. Looks good to me. Now let's calculate the size of our array, because we'll need to know how many times we're going to iterate through our array. So int size, I will set this equal to the size of operator, pass in our array. This will calculate the size of our array in bytes, and to find the number of elements, we can divide this by the size of just one element. So size of array divided by the size of array at index of 0. Size will equal the amount of elements within our array. And just to keep this code more organized, let's declare a function to actually sort all of this for us, so we don't have to do that within the main function. So let's declare a sort function. The return type is void, we're not returning anything, and let's name this sort. And there will be two parameters, an array of integers and integer size. And let's invoke this function. We're invoking sort, and then we need to pass in two arguments, our array and size. Within the sort function, we'll need nested loops. We can use for loops. So the outer for loop will be int I, set this equal to 0, and we will continue this for loop as long as I is less than the size of our array minus 1, and then increment I by 1. And then we need an inner for loop, so let's copy our outer for loop, paste it, and make a few changes. So the index for the inner loop will be j, and we'll continue this as long as j is less than the size of our array minus 1, then j++. Here's what we're doing within our array. So we will begin at our first index. We're checking to see if the element on the left is greater than the element on the right. If so, we're going to swap these two values, and we'll need the help of a temporary variable, much like what we learned in the last topic. So let's check to see if the element on the left is greater than the element on the right. If it isn't, we do nothing. So we need an if statement. If array at index of j is greater than array at index of j plus 1. We're adding plus 1 because we're checking the element directly next to the one that we're currently examining. So if the number on the left is greater than the number on the right, we will perform a basic variable swap. So let's declare a variable int temp to temporarily store some value, and I will set this equal to array at index of j. Now I need to move the element on the right over to the element on the left. Array at index of j equals array at index of j plus 1. And then lastly, whatever's within temp, I'm moving that to the element on the right. So array at index of j plus 1 equals temp. And that's it. So if you would like to optimize this, you can set size minus I minus 1. Basically, this is a bubble sort. So depending on the size of this number, it's going to find a final resting place. Since 9 is going to be the largest, it's going to be pushed all the way to the right because we will examine 9 against each of these numbers. So once 9 is pushed all the way to the right, all of these other numbers that are less than 9 will be on the left. So it's already partially organized, and now we just need some way to display the elements of our array. So let's declare a print function, void, and let's name this print array. And these will have the same parameters, an array of integers and int size. And this is a basic for loop. So for int I, set this equal to 0. We will continue this loop as long as I is less than the size of our array, and increment I by 1. And I would like to display each integer. And maybe I'll separate these with a space. And we are displaying our array at index of I. And all we have to do is invoke the print array function, and then pass in our array and our size. And let's take a look. Fingers are crossed. Oh yeah, there we go. Our array is now sorted. Now if you would like this in descending order, all we have to do is switch this if statement around from greater than to less than. And our array is sorted in reverse order. And we could sort an array of other data types too. This time, let's sort an array of characters. So let's declare an array of characters this time, and make up some characters. So then, to sort an array of characters, let's change the data type of our array to characters. And then when we display each character, make sure that we're using the C format specifier, because we were using D before. And this should now be sorted. Yep, so that's currently in reverse order, so then to switch that around, just change the sign. Alright, there you go. So yeah, everybody, that is a simple program to sort the elements of an array. This is a basic bubble sort, and if you're interested in learning more about sorting algorithms, I do have a playlist on data structures and algorithms. If you would like a copy of this code, I'll post this in the comments section down below, and well, yeah, that's how to sort a simple array in C. Okay, everybody, so let's talk about structs. A struct is short for structure. Think of it as a collection of related members, kind of like variables. They can be of different data types, unlike with arrays. Structs are listed under one name in a block of memory. In order to refer to that struct, we can refer to a variable name, and then we have access to that block of memory that contains related members. And lastly, structs are very similar to classes in other languages. If you're familiar with more than just C, you'll probably know what a class is, but there are no methods within a struct. It's only members. So we can actually use structs to mimic real-world objects. Let's say that maybe we're playing a game and we need 2 players. Each player will have a name and a score. These will be the members. So to create a struct outside of our main function, we will type the keyword struct followed by a tag name. Let's say we are working with players. Then we need a set of curly braces, then end it with a semicolon. So any members, think of these like variables. So let's say we have a character array named name, and I'll give this a size of maybe 12. So we will declare these but not assign them. We'll do that later. And we have an int named score. So each player is going to have a name and a score. Kind of like we're playing an arcade game. Now to assign some of these values, we're going to create a type of variable, and player is going to be kind of the data type. So we will type struct, then the tag name, which was player, and then a variable name. Let's say we have player1 and player2. So with these structs, you can reuse them. So we have struct player, player1, and struct player, player2. So we can assign values to these members. However, if we have an array of characters, we're going to use the string copy function. So let's use the string copy function. Then to access one of the members, you will type the name of that struct. So let's say player1, and then follow this with a dot. The dot is a member access operator. So after typing the dot, we have access to a name and score member. So let's set the player's name equal to whatever your first name is. Now if you're not working with an array of characters, such as an integer, you can just access these directly. So let's set player1's score to equal maybe 4 points. And we also have player2, but we have not assigned values to its members. So this time, let's assign player2's name and score. So we can just copy what we have, but change player1 to player2. Player2, let's say, is bra, and player2's score is 5. Now, if I would like to display these members, I can do so with a print statement. So printf, let's display our name first, so I will use the s format specifier, player1.name, and then I'll add a new line. Then to access player1's score, well, that's an integer, so I will use the d format specifier, player1.score. And then let's do the same thing with player2. So player2.name and player2.score. So we have our player1 struct's name member as bro and score member set to 4. And then our player2 struct has a name member of bra and a score member of 5. So yeah, that's basically a struct. It's a collection of related members. Think of these kind of like variables. They can be of different data types, unlike arrays, and they are listed under one name in a block of memory. So in this example, we have player1 and player2. Player1 and player2 refer to different blocks of memory, which contain their own unique members. If you're familiar with other programming languages, they're very similar to classes, but they cannot contain any methods. So yeah, those are structs. If you would like a copy of this code, I'll post this to the comment section down below, and well, yeah, those are structs in C. Alright, typedef. Typedef is a reserved keyword that gives an existing data type a nickname. Here's an example. Let's create a character array of 25 bytes, and we'll say that this is user1. So character, user1, and the size is 25 bytes. And then make up some username. So in this example, we have player 1 and player 2. Player 1 and player 2 refer to different blocks of memory, which contain their own unique members. If you're familiar with other programming languages, they're very similar to classes, but they cannot contain any methods. So yeah, those are structs. If you would like a copy of this code, I'll post this to the comment. Two number arrays, and they are listed under one name in a block of memory. So in this example, we have player 1 and player 2. Player 1 and player 2 refer to different blocks of memory, which contain their own unique members. If you're familiar with other programming languages, they're very similar to classes, but they cannot contain any methods. So yeah, those are structs. If you would like a copy of this code, I'll post this to the comment section down below, and well, yeah, those are structs in C. Alright, typedef. Typedef is a reserved keyword that gives an existing data type a nickname. Here's an example. Let's create a character array of 25 bytes, and we'll say that this is user1. So character, user1, and the size is 25 bytes, and then make up some username. Okay, so writing some of this syntax can be somewhat tedious. What a lot of C programmers will do is that they will use this typedef keyword to give some data type a nickname. Let's use this typedef keyword to give a character array of 25 bytes some nickname. So I'll do this outside of the main function. We will type typedef, then our data type. So this is a character array of 25 bytes, and we need some sort of nickname. So let's say that a character array of 25 bytes will be known as a user. Now I don't need all of the syntax now. I can type my data type, user, and then some variable name, let's say user1. From this point forward, if I need a character array of 25 bytes, I can call that a user. That's my nickname. Now one place where you see this used a lot is with structs. This time let's create a struct. At first we won't use the typedef keyword, and then I'll show you the benefits later. So let's say this is a struct, and the tag name is user. Users will have, let's say, 3 members. A character array named name of 25 bytes, a password of 12 bytes, and int ID, like an ID number. So to create a struct, we would have to type struct, then the tag name, user, and a variable name. And let's assign some of these values. I'll assign a name, password, and ID. Looks good to me. Okay, then if I need to create user2, I would type again struct user, some unique variable name, and make up some values. Okay, so with a struct, if I would like to use the typedef keyword, I will precede the struct keyword with typedef, and I don't necessarily need this tag name, and after the last curly brace, here I will add my nickname. I'll call this a user. If we need to create a user struct, we no longer need to use the struct keyword. We can remove this. And this should work, so let's print some of these members. And here are the 2 users that we created. Yeah, so in conclusion, typedef is a reserved keyword that gives an existing data type a nickname, and it's mostly used for convenience. If we use the typedef keyword when declaring a struct, we no longer need to use that struct keyword to create a struct. We can just use this nickname as the data type, and then come up with some unique variable name. So yeah, that is the typedef keyword. If you found this video helpful, please be sure to give this video a thumbs up, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey everybody, so in this video I'm going to show you how we can create an array of structs. Let's say we're working with students and we need to print each student's name and GPA. So let's create a struct. Outside of our main function, type struct and then a tag name for the struct, let's say student. So each student will have a name and a GPA. So let's create a character array named name. I'll set a maximum size of maybe 12 characters and a GPA. That could be a float. So float GPA. Now let's initialize some structs. We type struct, followed by the tag name, and then some variable name to identify each struct. So let's say we will have 4 students overall, and I'll go ahead and assign some values right away when we initialize this struct. So we need a name and a GPA. So the first student, let's say, is SpongeBob, and SpongeBob has a GPA of 3.0. So we can copy this and create a few more students. So student 1, student 2, student 3, and student 4. Next we have Patrick. Patrick has a 2.5. Then Sandy. Sandy is smart, so she has a 4.0. And Squidward. Squidward has a 2.0. So we have 4 students. Now we will create an array. So the data type of our array, what it's containing, will be structs. It will be struct student. It's kind of like the data type. So with an array, you have to declare what you're going to be putting within the array. Struct students, and then we need an array name. So this will be students, and then specify a maximum size if you need one. But I'm just going to initialize this array with some students. So let's add student 1, student 2, student 3, and student 4. And there we go, we have an array of structs. Now, if I would like to display each student's name, I can use a for loop to loop through our array. So for curly braces, we will create an index, int I, set this equal to 0. We will loop through this as long as I is less than, and then we need to calculate how many elements are within our array. So we have 4 elements, but we can do that by using the size of operator, pass in our array, and then divide this by the size of one of these elements. Size of students, and then pick maybe the first element of 0. After each iteration, we will increment I by 1. So then within our for loop, let's print each student's name. So let's use the s format specifier to display a string, and we will display our array at index of I, whatever our counter is, and we will use the member access operator of dot, so follow students at index of I with a dot. Then we have access to a name and a GPA. So let's display each student's name, and then I'll add a new line after each printf statement. So there we go, we have SpongeBob, Patrick, Sandy, and Squidward. Now let's display each student's GPA. So let's copy this line. We are displaying a float, so the format specifier for a float is f students at index of I dot GPA. Then I'll get rid of that new line character, and let's take a look to see what we have. Okay, we can see each student's name and GPA, but we may want to format this. So after each student's name, I'll add a tab, and I'll allocate maybe 12 characters to display each student's name, and then left justify it. And then with our GPA, let's display 2 digits after the decimal, so I will add .2. So this should look better. Yeah, that's much more organized. So we have SpongeBob with the GPA of 3.0, Patrick with 2.5, Sandy with 4.0, and Squidward with a 2.0. So yeah, that's how to create an array of structs. If you would like a copy of this code, I'll post this to the comment section down below. And well, yeah, that's how to create an array of structs in C. Well, welcome back. So enums, short for enumerations. They are a user-defined type of named integer identifiers. A benefit is that they help make a program more readable, either for us or for somebody else that's looking over our code. So here's how to create some enums. You can either declare these within the main function or outside of the main function. Let's do so outside of the main function. So to create some enums, type the keyword enum, followed by a unique identifier. Let's say we're working with days of the week. So let's say day, curly braces, and then end this with a semicolon. So enums are constants, and let's declare some constant names. Let's say the 7 days of the week. So separate each constant with a comma, and we will just go through the days of the week. Here are the enumerations that we declared. The days Sunday through Saturday, the days of the week. Now each of these constants has an associated integer. So beginning with your first constant, this will have a value of 0, then the next will have 1, then 2, then 3. Then you continue on in that pattern. But you can give these a unique value. Let's change Sunday to 1 because it's the first day of the week, then Monday will be 2, and then we will just continue with these. Now to use one of these enums, we would type enum, then our identifier name, day, it's kind of like a data type, and then some variable name, let's say today. And then you can set this equal to one of these constant names. Let's say that today is Sunday. So an important note with these enumerations, they're treated as integers and not strings. If I need to work with one of these enums, we're going to treat them as if they were an integer. So just for an example, I'm going to print the value contained within today. So this is going to be an integer, so we will use the D format specifier, and we will display today. So since today is equal to Sunday, this has an associated integer value of 1. And if I display that, this will print the number 1. If I change this to Saturday, well then it will print the number 7. So an important note is that enums are not strings, but they can be treated as integers. Now how does this make a program more readable? So let's write an if-else statement that's going to check what today is. First we'll begin with using the associated integer value. So if today is equal to 1 or today is equal to 7, then that means it's either Sunday or Saturday, and let's print a message. Let's say it's the weekend, party time, else we will print something else. I have to work today. So today is set to Saturday. That means that Saturday has an associated integer of 7. So if today is equal to 1 or 7, well then we will execute this if statement. It's the weekend, party time. I think I'm just going to add a new line real quick. Now if I set this to a different day of the week, let's say Monday, well then I have to work today. So the way that this is written now, it's not too readable. So instead of using an integer value, let's use the associated name with each of these constants. So let's replace 1 with Sunday and 7 with Saturday. And I'll change this to maybe Sunday. So this is a lot more readable, especially if somebody else is reviewing your code. They may not understand why today is equal to 1 or today is equal to 7, but this makes a lot more sense. Oh, so if today is equal to Sunday, or if today is equal to Saturday, then we print it's the weekend, party time. So that's a huge benefit with enums, is that they help make a program more readable. So to declare enums, you type enum, then an identifier, and then you can list as many constants as you would like, and you can give them an associated integer value too. So yeah, those are enums. If you would like a copy of this code, I'll post this to the comment section down below, and well, yeah, those are enums in C. Hey, what's going on everybody? So in this video I'm going to show you how we can generate some random numbers in C. Just as a disclaimer, these are pseudo-random numbers. They are a set of values or elements that are statistically random, so don't use these for any sort of cryptographic security. Now before we begin, include these two header files at the top, stdlib and time. The first thing that we're going to do is use the current time to generate a seed, which we need for random numbers. So we can use the srand function, s for seed, rand for random, and then we will pass in the current time function, pass in 0. So we will use the current time as a seed for random numbers. And then the function that you need to generate a random number using this seed is the rand function. So let's store our number within a variable, maybe number 1. Int number 1, and I will set this equal to, then invoke the rand function. Now the rand function will give you a random number between 0 and 32,767. So I'm guessing we probably don't need a number that large, So depending on the range of numbers that we need, we can use modulus and then the maximum number that you would like. So if I'm rolling at, and then we will pass in. Hey, what's going on everybody? So in this video I'm going to show you how we can generate some random numbers in C. Just as a disclaimer, these are pseudo-random numbers. They are a set of values or elements that are statistically random, so don't use these for any sort of cryptographic security. Now before we begin, include these two header files at the top, stdlib and time. The first thing that we're going to do is use the current time to generate a seed, which we need for random numbers. So we can use the srand function, s for seed, rand for random, and then we will pass in the current time. Time function pass in 0. So we will use the current time as a seed for random numbers. And then the function that you need to generate a random number using this seed is the rand function. So let's store our number within a variable, maybe number 1. Int number 1, and I will set this equal to, then invoke the rand function. Now the rand function 1, and then the function that rand function and time. The first thing that we're going to do is use the current time to generate a seed, which we need for random numbers. So we can use the srand function, s for seed, rand for random, and then we will pass in the current time. Time function pass in 0. So we will use the current time as a seed for random numbers. And then the function that you need to generate a random number using this seed is the rand function. So let's store our number within a variable, maybe number 1, int number 1, and I will set this equal to, then invoke the rand function. Now the rand function will give you a random number between 0 and 32,767. So I'm guessing we probably don't need a number that large. So depending on the range of numbers that we need, we can use modulus and then the maximum number that you would like. So if I'm rolling a 6-sided dice, I can say modulus 6. So the modulus operator gives you the remainder of any division. So technically this gives us a random number between 0 and 5 because computers always start with 0, but you can add an offset. So if I need the numbers 1 through 6, I can just add +1 to the end. And then maybe I'll surround this section with a set of parentheses just to make this more readable. So generate a random number between 0 and 5, add 1. That gives us a random number between 1 and 6. And let's just test that theory. So I'm going to use printf, and we are displaying an integer. And let's display number 1. So we should have a random number between 1 and 6. And our random number is 2. And if I run this again, this will be a different number probably. Yep, 6. Okay, now if I need to generate a couple different random numbers, I can just use this rand function again. So let's say we are rolling 3 dice. Number 1, number 2, and number 3. And then I'll print these as well. So number 1, number 2, and number 3. And I'll add a new line character after each of these print statements. Okay, so this will give us 3 random numbers between 1 and 6. 1, 3, 1, 3, 5, 6. Now it is important that we're generating a random seed. Let me show you what happens when I take this out. So this will give us the same numbers over and over again. 6, 6, 5. 665, and 665. So that's why it's important that we use a seed for random numbers. Now another thing too, if you need a larger number, you can just change this number. For example, I play a lot of Dungeons and Dragons, so I may need to roll a 20-sided dice, so I can just set this to 20. So 288, and let's try this again, 1254. So yeah, that's how to generate some random numbers in C. If you would like a copy of this code, I'll post this to the comment section down below. And well, yeah, that's how to generate some random numbers in C. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video we're going to create a number guessing game in C. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Hey everybody, so now that we know how to generate some pseudo-random numbers in C, I thought this would be a good opportunity for us to create a number guessing game. If we're working with pseudo-random numbers, be sure to include at least these 3 header files at the top of your program. So let's generate 2 constants, min and max. Const int, and a naming convention for constants is to make all of the letters uppercase. So minimum will be the minimum number that we will generate when we generate a random number. So let's pick a number between maybe 1 and 100. So min will be 1, and max will be 100, but feel free to take the liberty to choose some other numbers. And we'll need int guess to store a user's guess, int guesses to keep track of the guesses, and int answer. Okay, now if we're working with random numbers, we'll want to create a seed, and to do that we can actually use the current time. So use the srand function and pass in time, pass in 0. So this uses the current time as a seed to generate some random numbers. And if we need a random number between these two constants, min and max, this is what we can do. So we will assign answer, set this equal to, call the rand function, and use the modulus operator, and set this to max. And then we will add min as an offset. So this will generate a random number between these two constants, 1 and 100, or some other numbers if you have something different. So this line of code will generate a random number between min and max. Now before we actually move on, let's test this just to be sure that everything's working. So let's print whatever the answer is. So we're displaying an integer, we are displaying answer, and let's see what this is. Now before we min as an offset, so this will generate a random number between these two constants, 1 and 100, or some other numbers if you have something different. So this line of code will generate a random number between min and max. Now before we actually move on, let's test this just to be sure that everything's working. So let's print whatever the answer is. So we're displaying an integer, we are displaying answer, and let's see what this is. So my answer this round is 73. If I run this again, it is 93. Now if I change these values, we will adjust the range in which some random numbers will generate. So if I set min to 100 and max to 1000, that should change the range of numbers. And this time I have 334, but I'll change this back to 1 and 100. Okay, so we know that we're generating a random number, so let's move on. Let's create a do-while loop. So it's going to take at least one guess in order for somebody to guess the correct answer. So do, curly braces, we'll add while, and check a condition at the end. And the condition is guess does not equal answer. So let's create a prompt and ask the user to enter a guess. Enter a guess. And we will use scanf to accept some user input. So this is an integer, and we are storing this within guess. So address of operator, guess. Now that we have our user's guess, let's compare it to our answer. So we'll use an if statement and check to see if guess is greater than answer. So that means a user guessed a number that was a little too high. So let's print a message to let the user know. Too high. And then we can use an else if statement. Else if guess is less than answer, well then their guess was too low. Print too low. So if our guess is not greater than the answer or less than the answer, that means they must have got it right. So within an else block, let's print correct. So then after our if-else statements, let's increase guesses by 1. Guesses plus plus. The very best possible score a user can get is 1 if they guess it on the first try. So before we finish a while loop, we will increment guesses by 1. So then once we escape our while loop, let's print the user's final score. So we will print the answer. This is an integer, and we are displaying answer. And we will display the guesses it took. So guesses, and display the value found within guesses. And this part isn't necessary, but I like to add some text decorations. So maybe I'll add a bunch of asterisks to make it look nice. Let's run it. Enter a guess. I'll guess something right in the middle between, so maybe 50. So that guess was too low, so maybe 75? Okay, that was too high, so our number's between 50 and 75. How about 62? That's too low, so it's between 62 and 75. How about 69? That's still too low, so between 69 and 75, maybe 72? That's still too low, so it's between 72 and 75. 73? Alright, that was the right answer. I'm just going to fix one thing real quick. Let's add a new line here. And between 9 and 70. Add some text labeled. There's S's by 1. took. So, guesses, and display the value found within guesses. And this part isn't necessary, but I like to add some text decorations. So maybe I'll add a bunch of asterisks to make it look nice. Let's run it. Enter a guess. I'll guess something right in the middle between, so maybe 50. So that guess was too low, so maybe 75? Okay, that was too high, so our number's between 50 and 75. How about 62? That's too low, so it's between 62 and 75. How about 69? That's still too low, so between 69 and 75, maybe 72? That's still too low, so it's between 72 and 75. 73? Alright, that was the right answer. I'm just going to fix one thing real quick. Let's add a new line here. Okay, let's try this again. Okay, enter a guess. I'll try 50 again. That's too high. Maybe 25. That's still too high. What about 12? Too low. Maybe 18. Too low. 21. That's still too low. 23. Too low. 24. And 24 was the correct answer. Alright everybody, so I thought that would be a fun guessing game we could create for practice. If you would like a copy of all this, I'll post this to the comment section down below. And well, yeah, that is a simple number guessing game in C. Alright people, so now that we know how to create an array of strings, I thought this would be a good opportunity for us to create a quiz game. So before we begin, make sure to include these two header files at the top of your program. So let's begin with a 2D array of characters, and these will store our questions. And I'm going to set a maximum size for each question to 100 bytes. And we can go ahead and initialize this array with some questions. So remember, with strings, each string is its own array. So let's ask maybe 3 questions, but feel free to pick any amount that you like. And come up with any questions you would like as well. Or you can copy me, I don't care. What year did the C language debut? then separate each string with a comma. Then just to make this more readable, I'm going to go down to the next line. So this is question 2 now. Who is credited with creating C? And one more question. What is the predecessor of C? So now we have some questions. We'll need some options. This could be a separate 2D character array. Char, options, and I'll copy the dimensions from questions. And we'll create 4 sets of options for each question. This is the first set of options for the first question. And then let's add a second set of options for the second question. And a third set. Now we'll create an answer key. This will be a one-dimensional array. So char, answers, and the size will be 3. And I will set this equal to my answer key. So the correct answers for my quiz are B, A, B. So these will be individual characters, all separated with a comma. B, A, B. So let's calculate the number of questions that we have. So I will declare int number of questions and set this equal to size of operator, pass in our two-dimensional array of questions, and divide this by one of the elements because they all have the same size. Questions at index 0. And let's declare char guess to store our guess and int score to keep track of the player's score. So now let's begin this. I will print the title quiz game, then add a new line. Okay, now we need to loop through all of the questions, so let's use a for loop. So we will have an index of I set to 0, and I would like to loop through this as long as I is less than the number of questions that we have, then increment I by 1. And to test this, let's print our questions. So printf, we're displaying a string, so use the s format specifier. Questions at index of I. And then I'll add a new line character after each printf statement. Okay, let's at least test this. So we should cycle through our questions. Okay, here are my questions. What year did the C language debut? Who is credited with creating C? What is the predecessor of C? And this part isn't necessary, but I'm going to add some text decorations. I'll just display a bunch of asterisks. I'll do that before and after the question. And let's try that again. Oh, then add a new line character. That's a little bit better. After our question, let's display the possible options. So we will need a nested for loop. So for. Now this part's going to be a little bit tricky. We need to begin our for loop at every 4th string. Within our for loop, let's set int j equal to I times 4. So during the first iteration, I will be 0. So 0 times 4 is 0. But during the next iteration of the outer for loop, I is going to equal 1. So 1 times 4 is 4. So that way we will begin the inner for loop with every 4th string within our 2D array of options. And the condition is going to be j is less than I times 4, and then we would like to display 4 strings. This for loop will cycle 4 times beginning at every 4th string. And then we need to increment j by 1. Now let's print every option. So this is a string. I'll add a new line. And we are printing options at index of j. And let's test this just to be sure that it works. Okay, so we have our question followed by 4 possible options. Now let's accept some user input after the nested for loop. Currently our program isn't going to wait around for any user input. That's why it displayed all the questions and options. Okay, we will create a prompt to have a user type in a guess. Guess, and we will use scanf to accept some user input. We are accepting a single character and use the address of operator, guess. Now let me show you what happens when we run this real quick. So I'm just going to type in anything. Let's say A. Okay, so we skipped question 2. That's because after using scanf, when we accept a character, we have that new line character within the input buffer. So we need to clear that. So one way in which we can clear that is to use scanf again, use the C format specifier, and that's it. So this will clear the new line character from input buffer. So this should no longer just skip question 2. Okay, let's say A, B, C. Okay, so we know we can accept some user input now. Now here's one thing. What if somebody types in a lowercase character? I think that should still count, even though we're looking for an uppercase character. So let's take our guess and use the to upper function to make it uppercase. Guess equals to upper, then pass in guess. So basically we're passing in our guess, making it uppercase, and reassigning it to our guess. And let's write an if-else statement to check our guess if it's equal to our answer. So if else, our condition within our if statement, if guess is equal to answer at index of I. Remember that we're still within the for loop, the outer for loop, so we have that index. Oh, that's answers, plural. If a user's guess is equal to the answer, then let's print correct, and then give them 1 point. So printf correct, and then increment our score, score plus plus. Else we will print wrong. And you can give the correct answer if you would like, just do that within here. Now once we cycle through all of the questions, we can display a user score. So be sure to do that outside of the for loop, the outer for loop that is. So let's use printf and display final score. So I'm going to display 2 values. So the first will be the player score divided by the number of questions. So we have 2 integers to work with, and we are displaying score and number of questions. And then if you want, you can add some text decoration to make it look cool. So I'm going to run through this quiz once and intentionally get 1 question wrong. So what year did the C language debut? That would be 1972. That's B. Who is credited with creating C? Let's say Doc Brown. So D. And what is the predecessor of C? That would be B. Okay, and my final score is 2 out of 3. So let's try that again, and this time I will try and get 100%. So the correct answer is B, A, Dennis Ritchie, and B. And my final score is 3 out of 3. So yeah, I thought that would be a simple quiz game in C. If you would like a copy of this code, I'll post this to the comment section down below. And well, yeah, that's a simple quiz game in C. Hey everybody, let's talk about bitwise operators. These are special operators used in bit level programming. Knowing binary is important for this topic, so if you don't know how binary works, I would recommend skipping to the next topic. But if you're comfortable with binary, well, this video is for you. So let's begin. I'm going to discuss 5 different bitwise operators: and, or, exclusive or, left shift, and right shift. Let's create 3 variables, x, y, and z. X will equal 6, y will equal 12, and z will store our result, and we will set that to be 0. So I'm going to give you the binary representation of each of these numbers. So 6 is this number. So we have 8 bits, that's a byte. And this is the binary representation of the number 6. 12 would be this binary number. And 0 is easy. That would be all zeros. So let's use the AND bitwise operator. So what we're going to do is set z equal to x and y. So imagine this. Imagine that we're aligning all of these bits in columns. Using the AND bitwise operator, we're going to look at our operands x and y. If both of these are a 1, we will assign 1 to our result. And let's begin with the first column on the right. Both of these are zeros, so our result will stay at 0. And with the next column, we have 1 and 0. And using the AND bitwise operator, both of these need to be 1 in order to assign 1 to our result. So we will skip this column. Now with our third column, these are both 1, so we will assign 1 to our result. The next column is 0 and 1, we skip it, and the rest are just 0. So this binary number is the binary representation of the number 4. So let's test that. Z equals x and y, and let's print z. And equals, we're displaying an integer, I'll add a new line, and we are displaying z. And let's see if this is 4. Yep, our result, z, is equal to 4. Now let's move on to OR. So let's set this back to 0, and we will set z equal to x or y. OR is represented by a single vertical bar. And we will print OR. Let's try and guess what z is going to be before we actually display it. With the OR bitwise operator, only one of these bits needs to be 1 in order for us to assign 1 to the result. So since these are both 0, this will stay as 0. This bit is 1, this one's 0, so this would be 1. And for the next column of bits, these are both 1, so that counts as well. And we have a 1 in here, so that is 1. And the rest are just 0. So this is the binary representation of the number 14. And let's see if z is equal to 14. Yep, we got that right. So let's set this back to 0. Now with exclusive OR, that is represented by a caret. With exclusive OR, only one of these bits can be 1. If neither or both of these bits are 1, we don't assign anything. So both of these bits are 0, they will stay as 0. We have one of these bits as 1 and not the other, so that counts as 1. Now with this next column, both of these are 1, and using exclusive OR, only one of these can be 1. So since these are both 1s, we do not assign anything, so we keep that as 0. And with the next column, only one of these is 1, so we will set this to be 1 within the result. And this is the binary representation of 10. And let's test that. Z equals x exclusive OR y. And we will print exclusive OR equals z. And let's see if that's 10. Yep, z is equal to 10. Now here's left shift. We will shift these bits so many spaces to the left using left shift. So we will set z equal to x, and then left shift, which is represented by 2 left angle brackets, a number of spaces. Let's begin with 1. So we have x equal to 6. What we're doing is shifting these bits 1 spot to the left, and then adding 0 at the end. And this is the binary representation of the number 12. Actually, it's the same as y currently. These binary numbers are the same. And let's print that. So, shift left, and z should equal 12. Yep. And if I shift left twice, well then, we are just moving these bits 1 more space. And now, this is 24. There you go. So you probably noticed that there's a pattern. Every time we shift a binary number to the left, it effectively doubles. Now let's right shift. So let's copy this, paste it, and we will use 2 right angle brackets. And this is shift right. And let's set this to 6. If we're right shifting, we shift these bits 1 spot to the right, and this is the binary representation of the number 3. And if I print this, after shifting right once, our result z is 3. Every time we shift right, we're effectively cutting our number in half. Now if I shift right again, we will shift these bits 1 more spot to the right, and we are going to truncate this 1 at the end. And this will give us 1. That is the binary representation of the number 1. So technically half of 3 is 1.5, but we can't store that 0.5 portion, so it just gets truncated. Alright everybody, those are just a few bitwise operators. They are special operators used in bit-level programming. There's 5 that we discussed today, but there is another known as the complement operator, but that's a little bit more complex, and I might save that for another video. So yeah, those are bitwise operators. If you would like a copy of this code, I'll post this to the comment section down below, and well, yeah, those are some bitwise operators in C. Alright everybody, so let's talk about memory. Memory is an array of bytes within RAM, and a memory block is a single unit in bytes within memory. They're used to hold some value, and a memory address is the address of where a memory block is located within RAM. I like to think of memory as a street with a bunch of different houses. And each house is a memory block, which can hold some value, kind of like they're storing a person. And a memory address is the house address on that street where that memory block is located. So this would be a street address, like 123 Fake Street. So when we declare a variable, let's say we have char a. When we declare a variable, we are setting some amount of memory blocks aside to store some value. So the memory block that this variable is using up has some memory address. And if I assign this variable a value, let's say maybe x, well then if I was to go into my computer's memory and look for this address, I would find this character. So imagine we're walking down the street and we are looking for somebody's address. So we're going house to house and we find a matching address. If I were to open their front door, I should probably knock first at least, then I will find the character x. So that's kind of an analogy I like to use when thinking about memory. So let's declare a couple other characters. We have char b, I'll give this a value of y, and char c, and I'll give this a character of z. Okay, so let's find the size of each of these characters. So I'm going to use a printf statement. I'm going to display an integer, and the size of each of these characters is within bytes. So I'm going to use the size of operator and pass in one of my characters. So I'm going to pass in a, and I'll do the same thing with b and c. So the size of each of these characters is 1 byte, and I think I'm just going to add a new line here. Much better. Okay, now we can actually access the address of each of these variables. So each of these variables is using one block of memory. A single block of memory is a byte. So within a printf statement, I would like to display an address. So the format specifier is p, and I will use the address of operator, then the name of one of my variables. So I'll display the address of variables a, b, and c, and then display each on a new line. So here are the memory addresses for these 3 variables. These addresses are in hexadecimal. These are the street addresses of each of our memory blocks on our fictional street. Hey, so this is Bro from the future, just a quick crash course on hexadecimal values. With standard decimal values, they use the numbers 0 through 9, but with hexadecimal, you use the numbers 0 through 9 as well as A through F. So that gives you a total of 16 different values for each digit. So that's why there's a mix of numbers and letters. So each of these variables uses one memory block. They use 1 byte of memory. So beginning with variable A, this has this street address. But if we go down to the next memory block, you can see that there is just one change. F goes down to E, and then with variable C, this address goes down by 1. So F, E, D, these are contiguous memory blocks. They're all next to each other. But now if we switch to a different data type, like a short, we haven't used these in a long time. Well, shorts use 2 bytes of memory, as we can see here. So these hexadecimal addresses are now going down by 2. E, D, C, B, A. So each of these variables are using 2 memory blocks. We need an even larger house, even more memory blocks, and they use up 2 memory addresses. And then if I change these to integers, well, they're going to use up even more memory. So integers use 4 bytes of memory, and these are the street addresses of these 3 variables. And doubles use double the size of an integer. Doubles use 8 bytes of memory, and these street addresses are decrementing by 8. If this was a fictional street with houses, well, doubles use up 8 bytes of memory. So think of these like mansions. They're using up a lot of space. Now what happens with an array? I'm going to declare char a and declare an array. This will be an array of characters to begin with. So let's say character array b, and I'll give this a size of 1. So I'm going to print the size of a and the size of b, as well as their memory addresses. Our single character a uses 1 byte, and this is the street address of this variable. And our array b also uses up 1 byte, and this is the street address of where this array begins. If I set the size of this array to 2, well then my array is going to use 2 bytes, and now it has a different address to accommodate the increased size of the array. And if I change this to 3, it now uses 3 bytes of memory, and it has a new address. And if I change the data type of the array, we'll have to take that into consideration. So a short uses 2 bytes of memory, and we need 3 elements, so that's a total of 6. 2 times 3 is 6. And if I change this to int, an int uses 4 bytes, so 4 times 3 is 12. And a double is 8, so 8 times 3 is 24. So yeah, that's kind of the basics of memory. So memory is an array of bytes within RAM. Think of it like a street, and a street contains houses. Each house is a memory block that can hold some value. Think of each value as a person living in that house. And in order to find a person, we have to know their address, like a street address. C refers to these variables by their street address, but that's difficult for us to understand, so we just refer to this memory address as a variable name, because that's easier for humans to work with. So yeah, that's some basics of memory in C, and in the next video we're going to discuss pointers. So if you would like a copy of my notes here, I'll post them to the comment section down below, and well, yeah, that's the basics of memory in C. Hey, it's... Alright, what's going on everybody? It's your bro, hope you're doing well, and in this video... Hey, it's your bro, hope you're doing well, and in this video I'm going to explain the basics of pointers in C, so sit back, relax, and enjoy the show. If you wouldn't mind, please like, comment, and subscribe. 1 like equals 1 prayer for the YouTube algorithm. Oh yeah, we've finally made it to pointers. We're only about 40 topics in. A pointer is a variable-like reference that holds a memory address as a value to another variable, array, etc. Some tasks are performed more easily with pointers, and here's a comprehensive list of a few of the benefits. In this video, we're going to more or less focus on building a solid foundation with pointers and understanding how they work. So let's say we have a variable, int age, and I'll give this some value. A variable has a value and an address, and let's display the value and the address of this variable using 2 print statements. So first I'm going to display the address of this variable, address of age. Then I will use the p format specifier to display an address in hexadecimal. And we are displaying the address of age. And ampersand is the address of operator, address of age. And I would also like to display the value of age, value of age. And this is an integer, and we will display age. So variables have a value and an address. This is the address of this variable, and the value at this address. As you know, there's tons of different things we can do with a value of a variable, but there are things that we can do with an address as well. So we can actually store this address within a separate variable, a variable-like reference, and that is called a pointer. So to create a pointer, we will make sure these are of the same data type as the variable we're pointing to. Age is an integer, so we will declare this pointer of the integer data type. And the next step to declare a pointer is that we will use an asterisk. This is the indirection operator. And a common naming convention for pointers is that you type lowercase p, the name of the variable you're going to point to, but make the first letter uppercase. And I'm going to set this equal to the address of age. So the address of age and the value at this variable are the same. And let's test that theory. So this time I'm going to display the address of age and the value of p-age. And this will display an address, so change the format specifier from D to P. And I'm going to turn this line into a comment for now. Okay, so these addresses should both be the same. The address of age, as well as the value stored within p-age. So our pointer has its own address, but the value stored within it is an address. And we can access the value at this address by using the indirection operator. So this time I'm going to print the value of age and the value at stored address. And to dereference a pointer, you will type the pointer name, p-age, preceded with the indirection operator. As my own personal nickname for the indirection operator, I call it the value at address operator. That's not any official name, that's just how I think about it. So we're extracting a value at the given address within this pointer. So if I display the value of age and the value at this stored address using the indirection operator, well, both of these are going to be the same. So we have 21 stored within our age, and after dereferencing this pointer, we're extracting the value at this given address. So you use the indirection operator when you declare a pointer, as well as when you want to access a value at the stored address. So with the data types of the pointer, you'll want to make sure they're consistent. C is a strongly typed language, so if I change the data type of my pointer to char, using my compiler, I'll receive a warning. Initialization of char from incompatible pointer type, int. Now the actual data type of a pointer is the same. They use 8 bytes to store an address. So I'm going to print the size of our variable as well as our pointer. So I'll change this data type back to what it was originally. And this time I'm going to print the size of our age variable as well as the size of our pointer. Size of age, and we're displaying an integer, and this will be in bytes. Size of age, size of pointer age. And then I'm going to display a new line. Okay, so the size of our age variable is 4 bytes. It's an integer. Integers use 4 bytes. So even though we declared our pointer as an integer, the actual size of our pointer is going to be 8 bytes. That's enough to store a hexadecimal address. So just as good practice, since C is a strongly typed language, you'll want to be sure that the data type of your pointer is consistent with the variable that it's pointing to. Now here's one thing that we can do with pointers. We can pass a pointer as an argument to a function. So outside of my main function, I'm going to declare a function. Void, let's say print age. First we'll do this with passing an integer. So int age. And I will display the value of age. You are age, years, old. And I will display my age variable. Then at the end, we will pass in our variable. Print age, and I will pass in age. For now, I'm just going to turn all of these into comments. Okay, so, this works. You are 21 years old. You could also pass in a pointer too. So I'm going to, this time, pass in pointer age, and we need to change the parameter from an integer to a pointer. So precede the parameter name with the indirection operator, and I'll rename this parameter as page. In order to access the value of the address stored within my pointer, I need to dereference. So I will use the indirection operator, then type my pointer name, page, and this will do the same thing as before. So yeah, those are pointers. Oh, and before I forget, you can declare and initialize a pointer in 2 steps, but it would be good practice if you're declaring a pointer to assign a value of null. Since we already declared this pointer, we do not need to use this indirection operator again when assigning a value. So page equals the address of age. So it's considered good practice to assign null if you're declaring a pointer and not yet assigning a value. So yeah, that's basically a pointer. It's a variable-like reference that has a memory address as a value to another variable, array, etc. Some tasks are performed more easily with pointers, and to declare a pointer, you use the indirection operator. And if you need to access a value stored within a pointer, you type the pointer name preceded with the indirection operator. So yeah, that is a quick intro to pointers. If you found this video helpful, please give this video a thumbs up, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Alright, let's do this. Here's how we can write to a file in C. Let's create a file pointer. The data type is file, and I'll name this PF. It's a pointer to a file. And I will set this equal to, then invoke the fopen function. We will pass in a name we would like to give our file. Let's name this test.txt. But if you would like this to be a different file extension, such as HTML, well, you can change it to that then. We'll keep this as a plain text file just to keep it simple. And to write to a file, there is a second argument, a mode. So this could be W for write, A for append, R for read, but we are looking for W for now. So it is good practice at the end of your program to close any files that are open. So we will use the fclose function and pass in our pointer, PF. Make sure to not dereference it. Now to write a line of text to our file, we can use fprintf. Pass in our pointer, PF, do not dereference it, and then some string of text. Let's say SpongeBob SquarePants. So this file will be created in the same folder as my C program. So after running this, we have a new text file within the same folder, and it says SpongeBob SquarePants. What if I run this again and write something different, like Patrick Star? So if the mode is W, then we will actually overwrite any existing data already within this file. If we need to append a file, we can use the A mode for append. So this time, let's append some text to the end of our document. SpongeBob SquarePants. And you'll have to keep track of any new lines that you add too. So if I run this again, and this time I am appending some text, well, Patrick Star is still there, and we appended SpongeBob SquarePants to the end of our file. Now, if you would like to delete a file, here's how. I'm going to turn all of this into one giant comment. let's use a little bit of file detection. Let's check to see if our file does exist. Within our if statement, let's invoke the remove method, and we will pass in the name or location to our file, test.txt. If we remove this file successfully, it will return 0. So if after invoking the remove function, if this returns 0, that's its exit code, that means that file was deleted successfully. Let's print a message to let the user know. That file was deleted successfully. Else we will print a different message. Printf, that file was not deleted. Okay, let's try this. So here's my file within the same folder. If I run this, that file was deleted successfully, and that file is no longer within the same folder. You can see here that this says deleted. And if I run this again, we will not be able to locate that file because it's not there. Now you can write a file to a different location. Let's say I would like to write a file to my desktop. I can set a relative file path or an absolute file path. I'll use an absolute file path. I'm going to get the file location of my desktop, so I'm just going to click on one of these folders, go to Properties, and copy this location. So with my file name, I'm going to precede this with an absolute file path. Then any backslashes might need to be double backslashes. So this time, if I write a file, then this file will appear at this location on my desktop. And here's that file, test.txt, and it says SpongeBob SquarePants. Well, alright everybody, that is how to write, append, and delete files in C. If you found this video helpful, be sure to help me out by smashing that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Alright people, so in this video I'm going to show you how we can read the contents of a file someplace on your computer. You can either place this within the same folder as your C program or someplace else. I think it would be cool if we read a file from our desktops, so I'm going to create a new file, and this is going to be a plain text file, and I'll write a poem. I'll name this poem.txt. Here's my beautiful poem. Roses are red, violets are blue, booty, 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 rockin' everywhere. Okay, I'm going to save, and then I'll need the file location of where this is located. I'm going to right click, go to Properties, and copy this file path, and save it for later. Now to read a file on your computer, we'll need to create a pointer. The data type is file, and I'll name this pf. And I will set this equal to, then invoke the fopen function, passing your file. Mine is poem.txt. So if this file is not within the same folder as your C program, you'll need a relative or absolute file path. Since this file is on my desktop, I could use an absolute file path. So preceding my file name, I will paste that location. And then each backslash may need to be a double backslash because that is an escape sequence for a backslash character. Okay, the second argument is the mode. This time we are going to read a file, so pass in R for the second argument. Then it's good practice at the end of your program to close any open files. We will invoke the fclose function, pass in our pointer, do not dereference it. And we will need one more thing, a buffer. A buffer is going to act as a container, an array of characters to hold one line of our text document, one line at a time. So let's declare an array of characters named buffer, and I'll set the size to 255. Our buffer is going to hold one line of our file, one line at a time. And to read a single line from our file, we will use the fgets function, and there are three arguments. Our buffer, this is what we're inserting a line of text into, a maximum input size. I'll set this to be 255 to match our buffer, and then a pointer to the file that we're opening. And again, make sure to not dereference it. So this will read a single line of text, and then let's print our buffer. So we're printing a string, and we are displaying whatever is currently within our buffer. So after running this, this will read a single line of text, whatever's at the top. Roses are red. Now, if I need to read all of the contents of my file, I can place this section of code within a while loop. So with our condition, I'm going to move the fgets function within the condition. If we reach the end of a file, fgets will return null. So let's continue this while loop while fgets does not return null. If we do not return null, then we will print whatever's within our buffer. Now if I run this, this will display all of the lines from my file. Roses are red, violets are blue, booty 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 rockin' everywhere. And if you would like, you can add a little bit of file detection. So before we reach our while loop, let's check to see if that file even exists before we attempt to open and read it. So let's check to see if our pointer equals null. If it is null, that means we could not locate this file. So I'm going to print unable to open file, and we'll create an else statement. Else, let's read and print the contents of this file. Okay, so let's say I get the file extension wrong. Let's say I'm looking for an HTML file named poem, and I try and read this. Unable to open file, but if we are able to locate this file, we will open it and read the contents, and then close this file. So yeah, everybody, that is how to read the contents of a file line by line. If you found this video helpful, please winner is equal to player not return null. If we do not return null, then we will print whatever's within our buffer. Now if I run this, this will display all of the lines from my file. Roses are red, violets are blue, booty 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 rockin' everywhere. And if you would like, you can add a little bit of file detection. So before we reach our while loop, let's check to see if that file even exists before we attempt to open and read it. So let's check to see if our pointer equals null. If it is null, that means we could not locate this file. So I'm going to print unable to open file, and we'll create an else statement. Else. Okay, so let's say I get the file extension wrong. Let's say I'm looking for an HTML file named poem, and I try and read this. Unable to open file, but if we are able to locate this file, we will open it and read the contents, and then close this file. So yeah, everybody, that is how to read the contents of a file line by line. If you found this video helpful, please be sure to help me out by smashing that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro.